All right, people. I believe everybody's doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. In the today's session, we're gonna be talking about that is alternating current. Okay, one of the important chapters for NEET because when it comes to the EMI and AC, you guys can expect 3 to 4 questions from this portion. Alternating current, okay, and everything will be crystalline clear today. I'll be starting from the scratch, from the basics, okay, so all the things. And before that, I would want you guys to tell me in the chats if everything is perfectly fine, if I am audible, if I am visible to each and every single student. Let me know in the chats. Let me know in the chats quickly, guys. And most importantly, smash the like button. Smash the like button if you have not liked the session yet, because liking the session is extremely mandatory. Okay, and the session is not going to be too long. It will be the short session because the chapter is very small. Okay, it will take us 5 hours. Okay, maximum it will take us 5 hours. Okay. Great. Okay. Yes. So let the people join. Let everybody come and we are starting the session. We'll be starting the session. Let everybody join and we'll start. Let me know in the chats, guys, if I am perfectly audible. Let me know. Yes. Okay. Great. No. This is not going to be 10 plus hour session. This will be just 5 hours long. That's it. This is a small chapter. We'll be finishing and I'll be showing you all the problems, previous year questions, every single thing. Okay. We'll be discussing over here and we'll move on. And one more important thing I just want to tell you, when it comes to the next marathon, that is on Tuesday, that marathon will be for the complete modern physics. We'll be discussing 3 chapters. Okay. Dual nature of matter and radiations. Second is atoms and third is nuclei. Every single thing over there will be starting from the scratch. Okay. So be ready for that also. Now let's move on to this session. And guys, if you have not liked the session yet, I would want you guys to smash the like button. Everybody. Okay. Everybody, as soon as possible. Now guys, let's first talk about before starting the alternating current, okay, let's first talk about the direct current. We say, what is a direct current? See, I'll tell you. We say it is a unidirectional. It is a unidirectional current. What does unidirectional current mean? It is that current which has only one direction. It is that current which has only one direction. That is what we call the unidirectional current. And when it comes to the alternating current, that's a bidirectional current. Let me show you over here, my dear friends. Let's suppose if I make a battery over here, this is a battery. As of now, we have studied the battery looks something like this. This is a battery. Okay. And we call it DC source, which gives the DC current. And then if I make this resistance over here, the battery is connected to the resistance. We have studied before. This is the positive terminal of the battery. This is the negative terminal of the battery. We have studied the current always leaves from the positive terminal and it flows from positive to negative terminal. So this is the direction of the current in this particular circuit, from positive to negative. We do not say current leaves from the negative terminal and it enters the positive terminal. No, we say current flows from higher potential to lower potential. So I say in this case, the direction of the current is one. It is unique, and that is from positive terminal to negative terminal. And that's the reason we call this current as direct current. That current which has got only one direction, it flows only in one direction. So, my dear friends, if we plot the graph of this current, if I say plot the graph of this current, what will you do exactly? You will be making the graph of this current as, something like this. This is current, okay, versus let's suppose time. So I'll be making it something like this. Okay, I'm making it constant and it is positive. Current over here is positive. What does positive mean? Positive means current is flowing from this positive terminal to negative terminal. It has only one direction. So if you consider this current as positive towards the right and this current as negative in this case, so we say if it is flowing something like this, like over here, clockwise, so we consider it positive. It cannot be negative. It cannot flow in the anti-clockwise direction over here. So we say this is a unidirectional current. It has only one direction. Okay, yes. And this is what we call the direct current. Now, my dear friends, when the current is only positive, in that case, we say it is direct current. It is direct current. As simple as that. As simple as that. Okay. Let's suppose if I give you the question over here, is this AC current, alternating current or direct current? Which one? The value of the current is initially 5 ampere. Then it becomes 10 ampere. Then it becomes 15 ampere. Okay, like let me show you on the graph. Let me plot it on the graph over here. Let me plot this current on the graph over here. So let's suppose here value of current is 5 ampere. Here value, this is current versus time. Here value of current is 10 ampere. And I'm saying here value of current is 15 ampere. So first it says that the value of current is 10 amperes. Okay, let's suppose it starts from 10. Okay, and then it becomes 15. Then it becomes 5. Then it becomes 10 again, 15, 5, something like this. If you have studied AC before, the alternating current graph kind of looks something like this. But since if we talk over here, current is positive all the time. Here it is plus 5, plus 10, plus 15. When you see current is positive only, we say here current is positive only. No doubt current is changing its magnitude, but current is positive only. So we call this as direct current. We call this as DC. If I have made the graph something like this from the upper side and lower side, from the upper side we take current as positive, from the lower side we take current as negative. So then I call this as alternating current, AC. But since here we say this is a direct current. Why? Because the magnitude of the current is no doubt varying, but the direction is positive only. Direction is unique only. So current, see, it is like initially current was flowing, sir, 5 ampere, then increased 10 ampere, then increased, we say, sir, 15 ampere. But the direction remains the same. So we say it is a direct current. As simple as that. Is this clear? Please tell me in the chats, everybody out there. This is graph of DCs, graph of direct currents, graph of DCs. Guys, tell me in the chats if everything is crystalline clear. Yes, great. Now guys see, listen to me very carefully. So if I just make over here, in this particular case, let's suppose I'm making the graph of current versus time. So we say here current is positive only. So I call this current as, here the current is positive only. Okay. So current has only unique direction. So current is flowing something like this only. So I can say this current is DC. In this case, we say here current is made from the upper side only. So means current is positive. Here initially current is 0, 0, it becomes maximum. Then 0, maximum, 0, maximum. Okay. This is what we call the full wave rectifier. Okay. This is the graph of full wave rectifier. And this is also DC. This is also DC. Direct current. Cool. Yes. This is also DC. Just a second, guys. Okay. Now we have exactly over here. Let's talk about this one. Now, guys, in this particular case, we say here. Initially current is 0, then increasing, then it becomes constant. But you can see clearly in this case also current remains positive always. Here it is +5, +10, +15, then constant. Again, constant, positive. We say it is DC. It is a direct current. It is a direct current, or we say it is a DC. Next, let's talk about the alternating current. Let's talk about the alternating current. See, guys, we say it is a bidirectional. It is a bidirectional current. It is a bidirectional current. Okay. We say in this particular case, means that current, this can be positive as well as negative. This current can be positive as well as negative. Like, my dear friends, if I say, I'll make a circuit over here. Okay. This is what we call AC source. So it is that source which provides the alternating current. And I'll let's suppose connect a resistance with this. I'll connect a resistance with this. Okay. I can say in this particular case, current can flow something like this also. You consider this as positive current. Current can flow something like this also. You consider this as negative current. Here, negative current. Okay. So in this case, we do not say current flows from positive to negative terminal. We say here, it can flow something like this also. It can flow something like this also. So you consider this current as positive. You consider this current as negative. And if we try to make the graph over here, between current versus time, if we try to make the graph in this case between I versus t, I can say it can be something like this. From the upper side, we say current is positive. And from the lower side, we say current is negative. Okay. What does this negative current actually mean? Negative current means the direction of the current is just the opposite to the positive. So when the current has two directions, this is what we call the bidirectional current. Okay. Now, guys, let's take some of the examples over here of alternating current. If I say the graph of the current is something like this, okay, from the upper side current is positive, from the lower side current is negative. And you see, here current is 0, then it becomes the maximum, then it becomes 0, then becomes maximum from the lower side. So we say this is what we call the sinusoidal AC. This is the AC, but which one? Sinusoidal AC. Why? Because the graph is exactly like the sine curve. If you have seen the graph of sine x, sine theta, that is this one. That's why we call it the sinusoidal AC. Now, if you check over here, this is also the alternating current. See, graph from the upper side, it is positive. From the upper side, we say current is positive. Okay. And from the lower side, we say current is negative. And you can see in this particular case, initially current remains maximum and constant. Then changes the direction, here becomes negative. Then this is what we call the square wave AC. Initially current is constant for some time, then changes the direction. Okay, here it becomes plus I naught. from the lower side, this is what we call minus I naught. Negative peak from the negative side. Okay. Okay. In this particular case, this is not an AC. Why? Because here current is positive only. Current is positive only. No doubt the magnitude of the current is variable, but current is positive only. We say in this case, current is positive only. Positive only. Okay. And then we have got the triangular AC. What does triangular AC mean? If an alternating current is this, we say initially the value of current is 0, increasing, reaching maximum. Then decreases, and becomes negative. Maximum from the negative side, increases, maximum. And this is what we call triangular AC. And then we have this current something like this. From the lower side, it is positive, negative, positive, negative. This is what we call the sawtooth AC, sawtooth AC. Okay. And then we say in this particular case, you see amplitude of the current is decreasing. Means peak value of the current is decreasing. Here peak is large, then it becomes small, then it becomes small, then it becomes more small. Okay. So we say peak is decreasing in this particular case, not periodic. And in our chapter, we have to deal with this sinusoidal AC. Maximum number of times we have to deal with the sinusoidal AC. Okay. And guys, if you have not liked the session, smash the like button, everybody. Next. Let's now talk about over here. The sinusoidal AC bit more. Okay. Since, let's suppose if I say, my dear friends, if I say, we have studied previously. Let's suppose I have got a battery over here. And I'm saying this is the resistance connected with it. And the value of resistance over here is, let's suppose, 10 ohms. And this battery will have EMF or potential difference of 100 volts. And if somebody asks you, what is the value of current over here? What is the value of current, direct current over here? What will you say? You'll say, sir, this current is simply I is equal to V divided by R, Ohm's law. What is V? V is 100 in this case. And R in this case is 10. This and this will cancel, so it will come out to be 10 ampere. So value of this alternating current is basically how much? That is 10 ampere. Value of AC is 10 ampere. And we say, sorry, not AC, this is DC. And this is direct current. And its value is 10 ampere. So we basically represent this current like this: 10 ampere, 20 ampere, 15 ampere, something like this. Okay, because this is a direct current. And when it comes to, my dear friends, alternating current, how do we write the alternating current? I'll just write over here representation of AC. Okay, and more importantly, we talk about sinusoidal AC. Sinusoidal AC. Like if you have to write this current over here, how do you write? Will you show it, sir, 10 ampere, 15 ampere, 20 ampere? Or will you show with the help of an equation? When it comes to the equation of this AC, we write it something like this: I is equal to, we say I naught, then I can say sine of omega t. I naught sine of omega t. What is this I naught in this case? We say this I naught is what we call the peak value. Okay. Okay. This I naught is called the peak value. Peak value means here I can say, sir, this is the peak value in this particular case. What is the highest value that this current can have? Because this alternating current, we say this is a variable current. What can be the maximum value of this alternating current? That is what we call the peak value, I naught. Okay. Okay. Or we say this is the amplitude. Okay. Highest value, amplitude. Okay. And my dear friends, sine of omega t. Omega is what we call the angular frequency. And this is how do we show this alternating current. As of now, you remember this only, the sinusoidal current, AC current, we show it something like this. Okay. Yes. Now guys, First, we have amplitude over here. What does amplitude mean? We say the maximum value of current in either direction is called peak value and the amplitude of the current. It is represented by I naught. Okay. Okay. So basically, this is what we call the peak value. Let's suppose if you make the current over here, this will be the peak value. This will be the peak value. Okay. This will be the peak value. This will be the peak value. And then, my dear friends, we say time period. What is this time period? Like if I say this is omega and t. First, what is omega? Omega is angular frequency. If I say something, remember at this point of time, please do remember, because in the upcoming time, after some time, we'll be able to understand every single thing. So when it comes to this omega, we say this omega is also equal to 2 pi f. This is linear frequency. And this omega is also equal to 2 pi divided by, we say, t. And this t is what? This is the time period over here. Okay. Now, my dear friends, what is this time period? Time period means it is the time taken by an alternating current to complete one cycle. Let me make you understand. Let's suppose I'll make an alternating current over here. This is the alternating current that I am making. Now, guys, we say from this point to this point, this is called one time period. Means how much time it is taking to complete one cycle. Like if I say, let's suppose we have the pendulum. Okay. And pendulum starts its motion from this mean position and it goes till extreme. Okay. From here to here, how much time it will actually take? We say, sir, it will take t by 4. Time p, 1/4 of the total time period. Then it comes back. It will again take time t by 4. And then it goes to left extreme. We say it will again take time t by 4. Then when it comes back, it will again take time t by 4. Now t by 4 plus t by 4 is t by 2. T by 4 plus t by 4 is t by 2. We say t by 2 plus t by 2 will come out to be t. So one time period will takes how much time? T. How do we measure it? Guys, see one cycle. This is extreme and then it comes back. Then goes left extreme, then it comes back. This is one time period. So I say from here to here, let's suppose current initially is 0. Here current is 0. Then current becomes maximum, peak. Like over here, you can compare with the pendulum. It becomes peak, extreme. Okay. So this is, we say, sir, I naught. We say from I naught, we say from 0 to I naught, it is taking the time t by 4. From here to here, time is t by 4. And then from here to here, then again from peak to 0 once again, it takes time again t by 4. T by 4 plus t by 4 will be t by 2. And then again, it takes time t by 4 in this journey. From 0 to maximum. Okay, so it becomes 3t by 4. And then again, it takes time from peak to 0, t by 4. Then it becomes t. So t by 4 plus t by 4 plus t by 4 plus t by 4. Total is t. So this is what we call the one time period of AC. So this is one cycle of AC. And now if I extend over here, we say this is the another time period of AC. So from here to here, this is what we call 2t. So how much time an AC is taking in its one cycle? That's what we call the time period. So this is the peak value. How much time it is taking in the peak value? T by 4. Peak to 0. Once again, t by 4. T by 4, t by 4. Please give me the signal in the chats if everything is crystal and clear till over here. Tell me, guys. Okay. And that's how we define the time period. The time taken by an alternating current to complete one cycle of variation is called time period. And we say, when it comes to the frequency, guys, see, the number of cycles completed by an alternating current in one cycle. Guys, see. We say, this is the one cycle of this, and this is another cycle. I am saying current is initially 0, then becomes maximum 0, maximum 0. How much time in in 1 second, how many cycles it is completing? If I'm saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it is completing 10 cycles in 1 second. So that will be the frequency. Okay. So number of cycles completed in 1 second. Number of cycles, like this is the one cycle. Okay. This is another cycle. So we say it is completing 2 cycles in this particular case. So frequency is 2. Okay. Now. This one is done. This one is done. This one is done. Then we have got this. Now I hope you got the idea, basic idea of alternating current. So from now onwards, if you ever see the current something like this, you should know that it is an alternating current. And its equation would be something like this: I naught sine of omega t. Okay, something like this. Even it can be something like this also, I naught, we say cos of omega t. Because if you make the graph of this current, it would be something like this. It will start from maximum. Here also current is positive from the upper side. Here also current is negative from the lower side. Okay, so we have to study all. Don't worry about anything. So as of now, you remember this. Cool? Yes. Now guys, we have got over here average value. We have got over here average value. Or we say mean value. Sir, why do we have to study average or mean value? You'll get to understand everything. See, we say, if I write over here average for discrete quantities, when it comes to the average of discrete quantities, see, like you have the quantity x1 over here, you have x2 over here, you have x3 over here, you have x4 over here. Okay, so these are the quantities which are discrete. Okay, so x1 is some quantity, its value is fixed. Okay, x2 is some quantity, its value is fixed. x3 is some quantity, its value is fixed. Okay, and you are supposed to find average. How do you find average? We say, sir, if you have to find the average over here, you say in this case it will be x1 plus this quantity x2 plus this quantity x3 plus this quantity x4, and then we say whole divided by how many number of quantities? That is 4. If there are n number of quantities, you say x1 plus x2 plus x3 and so on up to n divided by n. Similarly, if I say you have got many currents over here, guys, if I say you have got current over here I1, you have got I2, you have got I3, you have got I4. Okay, the value of these current is fixed. Like I1 is 10 ampere, it will be 10 only. 15, it will be 15 only. And you have to find the average in this particular case. What will you say? You say add all of these, that is I1 plus I2 plus I3 plus I4, okay, and so on, divided by, we say if there are n number of quantities, we say this is In, so it is up to In divided by, we say n. Okay, this is how we find the average in case of discrete quantities. Now if I talk about continuous quantities, for a continuous quantity, like let's suppose we have got I is equal to 2t. Let's suppose we have got I is equal to 2t. Okay, if I is equal to 2t, then find average. Then you have to find average. Sir, what is continuous quantity? Continuous quantity is when the value of I can be anything. Like if you put t is equal to 1 over here, I will come out to be 2. If you put t is equal to 2 over here, I will come out to be 4. If you put t is equal to 3, I will come out to be 6. So we say at different time, value of this I comes out to be different. The value of I comes out to be different. Okay. So we say this is a continuous. Here, value of this x, I1, I2, this is fixed. Now, in this particular case, whenever you have something like this, from now onwards, you simply remember this bracket means to finding the average. It will be simply, that is integration of x dt. Integration of x dt upon, we say, integration of dt. Integration of x dt upon, we say, integration of this dt. This is how you are supposed to find the average. And one more thing, okay, and one more thing in this particular case, listen to me very carefully. That is, let's suppose if you have got like over here I, like you have to find the average of I. What will you do, sir? Integration of I dt, and then I say integration of dt over here. This will be the formula that you will be using. You have any quantity y, integration of y dt upon integration of dt. Okay. Now let's take a look at the question. We are done with this continuous. Let me delete this slide. Okay. Let's move on to the question we have got over here. The question is I is equal to 2t. To find average, we say from t is equal to 2 to t is equal to 5 seconds. We are supposed to find the average from t is equal to 2 to t is equal to 5 seconds. Okay. Yes. Now guys, when it comes to the average, we say it is simply integration of I dt, then we say integration of, we say, dt. And here I can write what is in I is given as 2t, so I'll write integration of 2t, okay, and this is dt, and then I'll write integration of, we say, sir, dt, and we are supposed to find average from 2 to 5 seconds. So put the limits from 2 to 5. This is how we find the average of a continuous quantity. Now guys, do the integration. Take this 2 out, and then we say in this particular case integration of t. Okay, and what is the integration of t? That will be simply t square divided by 2. Okay, and we say it is from 2 to 5. Okay, and divided by, we say integration of this t. Okay, now d and this will cancel, so it will be t only from 2 to 5. Okay, now this 2 and this will cancel over here in this particular case. So can I write, now put the upper limit in this 2, so it will be 5 square minus, then put the lower limit, that is 2 square, divided by 5 in the upper limit is 5 minus 2. Okay, 5 square is 25, and I can say 2 square is 4. So 25 minus 4, it will come out to be 21, divided by 5 minus 2 is, we say, sir, 3. 3 ones are 3 sevens are. So we say 7 ampere is the average of this from 2 to 5 seconds. Okay, 7 ampere. Great. Now guys, let's take a look over here. Let's suppose if somebody asks you, find the average value of sine omega t, what will you say? Guys, say, sir, it is simple. Sine of omega t. And if somebody asks you what is the graph of this sine, guys, see. We say graph of this sine will be simply this. This is the graph of sine. Okay, if it is sine theta, sine omega t, sine x, everything will have the same graph. And we say this is 0 and this is complete one time period t. And I'm asking you, find the average value of sine omega t, okay, in full cycle, I'll just write over in full cycle. What does full cycle mean? From 0 to capital T, full time period. So I can say over here, full cycle, in full cycle. Now guys, I want you to understand this. How do we find it, sir? Integration of sine omega t and then we say dt upon integration of, we say dt. Now from where to where? From 0 to t, from 0 to t. Because it is asking us to find the average in complete cycle from 0 to t. Now guys, if I say what is the integration of sine theta, sine x, that is minus cos x. So it will be minus cos of omega t, okay, minus cos of omega t, and then omega will go in divide and divided by omega. Coefficient of this t will go in divide. If it is sine of 2x, we say it will be minus cos of 2x divided by 2. And then integration of this dt will be simply, that is t. And here the limits are 0 to capital T. Here the limits are 0 to capital T. Okay, yes. Now guys, I would want you to understand. So we say this will be sine of omega t over here, and this is full cycle. Sine of omega t in full cycle. Now guys, put the upper limit over here. In this t, you have to put this capital T. So I can write this minus, put the limits. So you can say cos of omega into capital T, cos of omega into capital T, minus, then you have to put 0 over here. We say cos of omega into 0, cos of omega into 0. Then we say divided by omega. Here you put capital T minus 0, capital T minus 0, upper limit minus lower limit. So in this case, I can say this is minus. So I'll write cos of, guys, I recently told you this omega is also equal to 2 pi divided by t. Omega is 2 pi by t also. As of now, you please remember it. Omega is 2 pi by t. Now guys, we say here instead of omega, I can write 2 pi divided by t. And then you have got this t over here. Then minus cos of 0, okay. And then we say divided by, this is omega t. Now this t and this t will cancel. Now cos 2 pi is 360, okay. So I can say in this particular case that is 1. It will be minus cos 360 is 1, okay, minus, we say cos 0 is 1 divided by omega t, okay. 1 minus 1 is 0, 0 by this it will come out to be 0. So means average of sine omega t in full cycle is 0. Okay, average of sine omega t in full cycle is 0. And similarly, if somebody asks you the question, something like this, find the average of cos of omega t in full cycle. You have to use the same approach to find the answer in that particular case, and it will come out to be 0. Now, I will show you directly which you have to remember in this particular case. You don't have to follow everything. You have to remember it directly because this is going to help us in the future. We say full cycle and then we say half cycle. First, we have sine omega t. Average of sine omega t in full cycle, it is 0. We recently proved it. And then we have average of sine omega t in half cycle. Half cycle means from 0 to t by 2. Half cycle means from here to here, 0 to t by 2. Okay. So it is 2 divided by pi. Then we say average of cos omega t in full cycle is also 0. And average of cos omega t in half cycle is 2 divided by pi. Then we say sine square of omega t. Okay, sine square of omega t. Its average in full cycle, it is 1 by 2. Cos square of omega t, its average in full cycle 1 by 2. Sine square of omega t, its average in half cycle is 1 by 2. Cos square of omega t in full cycle, its average in full cycle 1 by 2. All of these you have to remember, keep these things in your mind, because in the examination hall or tomorrow or today only when we solve the question, you won't be able, at that point of time, you don't have to solve these. You should be able to remember all of these because we'll be applying these directly. Okay, yes. Now we have got first question on the screen that we will solve over here. Now guys, see. Before this, I'm saying, let's suppose we have this alternating current. Since I'm talking about the value of this alternating current is changing. Here the value of alternating current is 0. Then it becomes maximum. Here it becomes something else. So means it is taking time in changing the value. If I'm saying, what is the time taken by the alternating current from 0 to maximum? You say, sir, you'll have to find that out. Now, on that only we have got the question. See guys, don't get confused. We say, in an AC, the current is expressed as, we are given an alternating current over here because we know alternating current looks something like this. So alternating current is given as, we say 200, and then I say sine of 200 pi t, sine of 200 pi and t. Okay. If you compare it with, we say compare with, we say I is equal to, we say I naught, then we say sine of omega t. So here I can say I naught is basically 200, means peak value, amplitude of this current is 200, and sine of omega t, and omega in this case is given as 2 pi, and here is t. Omega in this case is given as 200 pi, not 2 pi. It is given as 200 pi. Okay. Now it says that this is the alternating current. In this circuit, current rises from 0 to peak value in the time. Now if you try to make the graph of this current, it would be something like this. I have already told you. It would be something like this. Okay. And when it comes to the peak value, peak value is, we say, sir, 200, because this is the peak value, highest value. Now, in this case, what I'm trying to say is that from 0 to peak value, it has taken some time. From 0 to peak value, it has taken some time. Sir, how much? T by 4. Yes, I know T by 4, but you have to find the exact value of that T by 4. How much time it is taking to rise from 0 to peak? This 0 to peak, how much time it is taking? Now see, I'll show you the approach, how to solve these types of questions. Guys, see, what is this I? This I is called the instantaneous current. Instantaneous current means its value can be anything. When t is equal to 0, value of this current is 0. When t is t by 4, value of this current is maximum peak. Okay. Now, let me show you the approach. We say we have to find the time in which current rises from 0 to peak. Okay. We say put, what is the peak value over here? 200. We say put I is equal to 200 in equation first. Why, sir? So I'll just write first. So it will be 200 is equal to, we say 200 sine of 200 pi t. Why are you, sir, putting peak value over here 200? Because it says that what is the time when this current reaches peak, when its value is 100. Okay. So my dear friends, what I'm trying to say in this particular case is, if it has asked what is the time taken by the current to reach 50 ampere, then in that case, I would have put over here the 50 ampere only. So this is how we solve the question. So my dear friends, Now this 200 and 200 will cancel over here. Okay, so I'll say this is 1 is equal to sine of 200 pi t. Now tell me, when is the value of sine as 1? It is sine 90. So I can write over here, this is sine of pi by 2. And then I say this is sine of, we say 200 pi t. Okay, now this sine and sine goes, pi and pi goes. So it will be 1 by 2 is equal to 200 into t. So can I say 202 is 1 by 400? So t will come out to be 1 divided by 400 seconds. So after 1 by 400 seconds, the current will reach its peak value, maximum value. So after 1 by 400 seconds, current will reach its peak and maximum value. Is this clear? Now guys, listen to me very carefully. Listen to me. So what did I say? If it has asked how much time it is taking in reaching the 50 ampere, then you have to put I is equal to 50. Next, you have this. The peak value of an alternating EMF. First is what we call the alternating current. And then we have the alternating EMF. Like. If you say, guys, see. If you say, this is a battery over here, it has got 20 volt potential difference. This is the what we call the DC source, which provides the direct current. So we write 20 volt, 30 volt, something like this. When you have the alternating source, I'll show you after some time. When you have the alternating source, which gives the alternating current, so it will have the EMF something like this. E is equal to, we say E naught sine of omega t, cos of omega t, something like this. It is exactly like the alternating current. It looks like the alternating current. Like this looks like the direct current. This looks like the alternating current. And this is what we call the AC source. And this is the alternating EMF. And in this case, we have a battery which has the alternating EMF of E is equal to E naught cos of omega t. Okay. Yes. Then it says that. And frequency is 50 hertz. Okay. The peak value of an alternating EMF is 10 volts. It says peak value E naught is given as 10 volts. And frequency F is given as, we say, 50 hertz. F is given as 50 hertz. Then it says at time t is equal to 1 by 600 seconds. I'll show you more questions on that. Chill. We say at time t is equal to 1 by 600 seconds. Time is given as 1 by 600 seconds. The value of instantaneous EMF is, you are supposed to find the value of this E. When time is 1 by 600 seconds, you have to find the value of EMF. Guys, smash the like button if you have not liked the session yet. So we say put all these values in the equation 1. Put in equation 1. Call this as equation 1. Now, can I write this as E is equal to, guys, what is the peak value over here? That is given as 10. And then we say cos of. Can we write omega as 2 pi f? I'll write, sir, 2 pi into f. Then we say this is t. So I can write over here, this will be 10. And then we say cos of 2. And this pi as it is. Keep the pi as it is. And what is frequency? Frequency is given as 50 hertz. Okay. And then we say time. Time is given as 1 by 600 seconds. So this and this will cancel. 5 ones are 5 12s are. Now 2 ones are 2 6s are. So it will come out to be E is equal to 10 cos of pi by 6. Cos pi by 6 is cos 30. Cos 30 is equal to how much? Root 3 by 2. So E will come out to be 10 into root 3 by 2. This and this will cancel. So it will be 2 root 3. 5 root 3 volts. So the value of instantaneous EMF is simply how much? That is 5 root 3 volts. Okay, that is 5 root 3 volts. Just you have to put all of these values in this one and you'll get the answer. That's it. That's it. Now, let's move on to, that's what we call the RMS value. Let's move on to RMS value. This is also what we call a root. This is also what we call, we say, root mean square value. This is also what we call the root mean square value. Okay. This is also what we call the root mean square value. Okay. Now, guys, listen to me very, very, very carefully. Listen to me very, very, very carefully. I want you to understand one thing. I want you to understand one thing. What is that? See. Let's suppose you have got I is equal to I naught, we say sine of omega t. Okay. And I am saying that find its RMS value. First, I'll show you how do we actually find the RMS value. Then I'll make you understand what this RMS value is all about. Okay, cool. Now we have got this alternating current as I is equal to I naught sine of omega t. Cool, sir, absolutely cool. Now it says that step one. What is step one? Step one is we say root mean square. You have to do the squaring. Do the squaring. Okay. So I do the squaring of this current. This is I square is equal to. Then we say I naught square. Then we say sine square of omega t. First we have to do the squaring. Then step two. It says, okay, find the mean. Mean means average. We say then find mean. Okay, mean means finding the average. And how do we find the mean? Guys, this is how do we find the mean. Okay, put the brackets over here. And then I can say this is I naught. Okay, and then I say sine of omega t. Now guys, in this case, I want you to focus over here. In this case, this is a sinusoidal current and you are finding its average. See. This I naught peak will always come out of the average because I naught is constant. Okay. So I say this is sine of omega t. Could you please tell me what is the average of sine omega t? We say average of sine omega t. Guys, in full cycle over here. We say average of sine omega t in full cycle is how much? We say, sir, 0 in this particular case. Okay. So it is sine square of omega t. Sorry. It is sine square of omega t. It is first we have to do the squaring. Then it will be square. This is square, and this is square. Okay. Now in this particular case, now check. What is the average of sine square of omega t? It's 1/2. Even in the full cycle, even in the half cycle, it is 1/2 and 1/2 only. Okay. Now we are done with the squaring. So I can write over here, this will be simply that is I naught square. And what is the value of this? It will be simply that is 1/2. 1/2. And then next we have third step. What are we going to do? That is we say apply the root. So when you apply the root after this, guys, you have I square, then you find the average and then you apply the root. This is what we call the IRMS, root mean square. And then it will be apply root over here. It will be under root of I naught square and then under root of 1/2 because this is under root of I naught and 1/2. Now tell me, guys, what is this? This and this will cancel. So it will be I naught divided by a root 2. So this came out to be the value of IRMS. So from now onwards, if you are given the alternating current, they ask you to find the average, what will you say? You say, sir, this IRMS will be simply, that is peak value, I naught is peak value divided by root 2. So you take the peak value and divide it with the root 2, you'll get the IRMS value. Okay. Okay. Like example, if I say, I say in this particular case, if I is equal to 10 sine of 100 pi t, find IRMS. Can I say in this particular case, when it comes to the IRMS, that will be I naught by root 2, and that will be 10 divided by root 2. Peak value divided by root 2. Guys, give me the signal in the chats if everything is crystal and clear till over here. Tell me. Tell me, guys. Great. Guys, smash the like button. Now see, equation for an alternating current is given this. Okay. I can write over here, this is given as I is equal to, we say 10 root 2. Then I'll write sine of, and it is 100 pi t plus we say pi by 6. Okay. And the time taken by the current, to reach its root mean square value. Now guys, see. It is something like this. Let's suppose if I make the graph of this current. Since this is a sinusoidal current, graph would be the sine curve. It says that how much time it takes to reach the root mean square value. Guys, here value of current is 0. Here value of current is I naught. This is the peak value. Now I say how much time it will take to reach the root mean square value. Let's suppose here it is the root means IRMS value. So from here to here you are supposed to find this time. Now I say first, as let's find IRMS. When it comes to the IRMS, that will be I naught divided by root 2. And what is I naught over here? I naught is 10 root 2. This is always, we say this is the peak current divided by root 2. Now put this 10 root 2 divided by 10 root 2 is equal to I. Because I told you, if they ask you to find the time in which current reaches 50 ampere, put 50. If they ask you to find the time in which current reaches IRMS, put this as IRMS. So here we will put that is 10 root 2 divided by root 2 is equal to, we say 10 root 2, and then I can say sine of, we say 100 pi t plus pi divided by 6. Okay. Now guys, here what I can do is we say this and this will cancel. So it will become 1 by root 2 is equal to, we say sine of 100 pi t plus we say pi by 6, something like this. When is the value of sine as 1 by root 2? You say, sir, 1 by root 2 means sine of pi by 4, sine 45. Sine 45 is 1 by root 2. So you can write over here, this will be sine of, we say 100 pi t plus we say pi by 6 plus we say pi by 6. Okay. Yes. Now guys, this sine goes, pi goes. So can I write in this particular case? So from this side it is 1 by 4. From this side it is 1 by 4 is equal to, from this side it is 100 t plus we say 1 by 6. If you take it to the another side, 1 by 4 minus we say 1 by 6 is equal to, we say 100t. Now do the cross multiply. 6 minus 4. 6 minus 4 is 2. 2 divided by 24. 2 divided by 24. 2 divided by 24 is equal to 100t. So 2 ones are 2, 12s are. So t will come out to be 1 by 1200. Okay, seconds. T will come out to be 1 by 1200 seconds. T will come out to be 1 by 1200 seconds. Okay, so in this time, the current will reach its IRMS value. The current will reach its IRMS value. Okay. Now guys, let's talk over here in this question. A resistance of 40 ohms connected to an AC source, of 220 volts. Before this, I just want to show you one thing. That is this one. Okay, let's solve this question first. See guys. Or we can solve this also. See. Let me just directly tell you this. A resistance of 40 ohm is connected to an AC source of 220 volts. Guys. I want you to understand one thing. What is that? When it is mentioned, okay, before this question, you have to understand this representation of AC. Wait for this. See, let's solve this. This is the simple one. Now see, in this particular question, it says the current flowing in an AC circuit is given as I is equal to 5. Then we say sine of 120 pi t. How long the current will take to reach the peak value? Peak is how much? 5. So put I is equal to 5 over here. This will be 5. Then we say sine of 120 pi t. By the way, this is a previous year question. This and this will cancel. It is 1. So I can write over here sine of pi by 2 is equal to sine of, we say, 120 pi t. This and this will cancel. Pi and pi will cancel. So 1 by 2 is equal to 120 into t. So t will come out to be 1 by 240 seconds. So in 1 by 240 seconds, t will be, it will reach the peak value. Now see guys. This is the, first you have to understand this. See. The representation of DC, direct current. How do we actually show a DC source? DC source means the battery that we have been studying till now. So this is 220 volts over here. This is positive terminal. This is negative terminal. This is what we call the direct current source. This is that battery. This is that source which gives you the direct current. Okay. Now we say this 220 which is mentioned is peak instantaneous RMS average, because this is constant DC. Guys. I told you how to find RMS. Okay, we say, sir, IRMS. But in real life, what is the meaning of this RMS? Guys, understand this very carefully. In real life, we say this is your home. Okay. You have got the refrigerator, you have got the television, okay, a lot of instruments you are using in your home. So this is the government sending you the electricity supply from the outside. So we receive this electricity in the form of AC. And then we store it in the form of DC. You have got the battery at your home, inverter at your home. What is inverter? Inverter converts the alternating current into direct current that stores the AC in the form of DC. So we can store DC, we cannot store AC. AC is used for the transmission purposes. So from the outside, you are getting this alternating current AC. Okay. Now, if you say, sir, we are getting this alternating AC from the outside, are we getting RMS? Are we getting, we say, sir, peak? Which current they are sending us from the outside? Okay. What is, if we say, sir, you are saying, guys, you say, sir, we have 220 voltage. We have got a great voltage in our society. Okay, we have got good electricity, good voltage in our society. Sir, this voltage, is this RMS voltage? Is this peak voltage? Okay, is this average? Which voltage is this? Please make us understand. This which you are getting from the outside, which government is sending you for domestic purposes, this is what we call the RMS. This is what we call RMS. So we say RMS is that voltage which is being sent by the government in your homes so that you can use the current electricity. Okay, we say it is not peak voltage, it is not average, it is what? RMS. It is what? RMS. Okay, okay. So my dear friends, if I say in this particular case, we say IRMS. If I say IRMS, so means if I say I'm getting the supply of 220 volts, I'm getting the supply of 200 volts. Okay, voltage is 200, voltage is 210. So we say this is what we call the RMS voltage that is sent by the government over here. From now onwards, you'll be remembering. So for the domestic use, domestic purposes, we use RMS voltage. Okay. Now, when it comes to the DC over here, and sir, if it is, guys, if I say current is given as I is equal to that is 200, and then we say sine of 100 pi t. Sir, what does this actually mean? This is what we call peak over here. And from peak, how to find IRMS? You know that IRMS is equal to 220 divided by root 2. And this is what we call the RMS. Okay. Now, when it comes to the DC source, we say this is the constant. This is constant. So if there is a constant, there is a quantity which is constant, we say its RMS is that only, its average is that only, its peak is that only, its instantaneous is that only. If I am saying you have got a current of 10 amperes, sir, is this RMS peak? Everything. It is everything because it's constant. It's constant. And but if the current is changing, we say then RMS can be different, peak can be different. Okay, instantaneous can be different, will be different at every point. Average will be different. Okay. Now, let's talk about which one. We say DAC source. This is the representation of AC source. This is how we represent it. Okay. Now we say this is 220 volts, 50 hertz. If from now onwards you ever see an AC source, something like this. Here, this 220 volts means RMS voltage. Okay. And 50 hertz is the frequency. Okay. It means it can change its direction 100 times in 1 second. If 50 hertz is the frequency, my dear friends. Okay. High, low, high means positive, negative, positive, negative, positive, negative. So from now onwards, guys, there are two things. I don't want you guys to confuse yourself. There are two things. We say, if you ever see an AC source, something like this, okay, and it is mentioned 220 / 50 hertz, 70 hertz, whatever it may be, okay, then take this, consider this as VRMS. This is the RMS voltage. But if you ever see an alternating source and it is given E is equal to, we say 220 sine of 100 t, then in that case you take this as peak. Then in that case you consider this as peak. If only it is mentioned 220, then it will be RMS. That's what is mentioned over here. Okay. Next. And if peak is given, you can find the RMS easily. Okay, you can find the RMS easily. Or if RMS is given, you can find the peak easily. VRMS is equal to V0, okay, divided by root 2. I'll teach 11th syllabus also because last year we couldn't continue with this series. That's why I couldn't complete the 11th portion. But this year we started early because last year we started this series, I guess, in the month of January. So that's why we couldn't get the enough time to complete all the chapters. But this year we started it very early. We have a lot of time left and I'll be completing all the chapters. So chill, take a chill pill. You don't have to worry about anything. That's my job. I'll do that. Okay. No, IRMS is the RMS current. VRMS is the RMS voltage. Okay. Okay. Now see, I have discussed all of these. If VRMS is given and you are supposed to find the peak, so multiply it over here, you will get peak voltage. Here, if it is something like this and peak is given, you are supposed to find the RMS, so V0 by root 2, peak by root 2, and that will give you the RMS voltage. Okay, IRMS is RMS current, VRMS is RMS voltage, potential difference current, voltage current. Okay, I hope this is crystal clear to each and every single student. Okay. Yo. Okay, let's talk about this. Average of sinusoidal current. Average of sinusoidal current. See guys, when it comes to the average of sinusoidal current over here, see, let's suppose we have got a sinusoidal current. I is equal to I naught sine of omega t plus phi. And you are supposed to find average. Okay. Let's suppose in full cycle. Tell me one thing, my dear friends. How do we find the average? We say average of this I will be simply average of, that is I naught. We say sine of omega t plus phi, whatever it may be. Okay. Now this peak is constant. Take this constant out. Then I can write over here sine of, we say omega t plus we say phi. Okay. Then can I write in this particular case, my dear friends, this will be I naught. What is the average of this? What is the average of sine of omega t plus phi? We know average of this in full cycle, it is 0. Okay, so it will be 0. So it will come out to be 0. So average of sinusoidal current in full cycle is 0. Okay. So you can write from now onwards, average of sinusoidal current in full cycle is 0. Let's talk about average of sinusoidal current. Average of sinusoidal current in half cycle. I can say average of this sinusoidal current in half cycle. So that will be simply this average I naught, then I'll write sine of omega t plus phi, okay, in half cycle. Now take this I naught out over here, so I can say this is I naught, and then I'll write sine of omega t plus phi. Okay, now what is the average of sine omega t plus phi in half cycle? I have told you previously in this slide, sine of omega t in half cycle is 2 by pi. Its average, as we said, 2 by pi. So I can write over here, this will be simply, that is I naught, and then I'll write 2 divided by pi. So this average in half cycle is simply, that is 2 I naught divided by pi. 2 I naught divided by pi. Okay, this is 2 I naught divided by pi. Sir, what is pi? Pi is qt pi. Okay. Now guys, yes, I'll try to finish within December. Okay, so chill, because you have only one physics teacher on the channel, so it takes time as compared to the chemistry people. Now guys, see, we say I is equal to 10 sine of, okay, you have got over here, I is equal to 10 sine of, and one more thing, this is average in half cycle, average in full cycle, and how to find IRMS, that will be I naught by root 2. Okay, I naught by root 2. And next, I would want you guys to focus over here. Okay, this average, okay. You have got the alternating current in this particular case, that is 10 sine of omega t, and then I can write plus pi by 6, plus pi by 6. You are supposed to find the average current, RMS current, half cycle, full cycle. Okay. When it comes to the I average in full cycle, so we say it is 0. When it comes to the I average in half cycle, we say it is 2 I naught divided by pi. And what is the value of I naught over here? Peak, that is 2 into 10, that will become 20 by pi. And when it comes to IRMS, we say IRMS will be simply I naught divided by root 2. So what is the value of I naught? That is 10 divided by root 2. As simple as that. Okay. Now, next thing, you have got mixture of AC and DC. If there is a current which is mixture of AC and DC, this over here is direct current, DC. It is plus this, and this is, we say, sir, alternating current. And if you ever see the mixture of AC and DC, and they ask you to find the IRMS, directly I would want you guys to focus over here. Okay. We say you consider this as I1. You consider this as, we say, I2. You consider this as I1 and you consider this as I2. And second thing is over here, my dear friends. That is, we say, if you want to find IRMS in such cases, so what is the general method? First, you do the squaring of this, then find the mean average, then put the root, that will be the RMS. But directly, I want you to remember, we say, for AC and DC, mixture of AC and DC, I say it is under root of, we say I1 square plus, I1 is direct current, I2 is AC. With this alternating I2 square, divide with the root 2. It is I2 square, divide with the root 2 over here. That's it. Now here in this case, it will be under root of I1 is 4 square. Then we say plus I2 is 5 square divided by, it is divided by 2. Okay. Now solve it and get the answer. It is divided by 2. Okay. So solve it and get the answer. Just a second, bro. I myself forgot. Okay. It is actually, so the regular method is basically do the squaring, integration, and then root 2. Okay. Yeah, it is divided by 2. It is not divided by root 2, it is divided by 2 only. Okay. Now solve this and you'll get the answer. 4 square is 16. 5 square is 25 divided by 2. And what is the normal approach? How do you find it with the regular long method? First, do the squaring, then find the mean, and then apply the root. You'll be able to find. And directly with the shortcut trick, this is the way you can find the answer. Okay. Next. Like here. How do you find the IRMS in this particular case? Guys, we say IRMS in this particular cases. This is I is equal to 2 plus 3 sine omega t. This will be I1. This will be I2. So it will be, again, you can say this is I1 square plus, we say, I2 square divided by 2. Okay. Now put the values and get the answer. So 2 square plus 3 square divided by 2. This will be the value. Next. Okay. If an alternating current is given by I1 cos theta plus I2 sin theta. See guys. We say alternating current is given as I1 cos theta, I1 cos omega t, cos of omega t plus I2 sine of omega t. Guys, in this particular case, we said this is mixture of AC and AC. We say this is over here alternating current. This is also the alternating current. We say this is mixture of AC. Mixture of ACs. Previous one was the mixture of AC and DC. Okay. This is mixture of ACs. And in this case, if they ask you to find the IRMS, you simply say under root of, we say I1 square plus I2 square divided by, we say 2. Okay. This is how we find the RMS value when you have the mixture of AC and AC. Okay. Now, if I give you in this particular case, let's suppose if I give you I is equal to 2 cos of omega t plus 3 sine of omega t. What will you do in this particular case? Sir, IRMS will be simply under root of, because this is AC, this is AC. That is 2 square plus 3 square divided by 2. As simple as that. As simple as that. As simple as that. Now, guys, listen to me very carefully. Already discussed this thing. I hope you remember now. We say sinusoidal AC. If you have got the sinusoidal AC, this is the graph. This is the peak value. This is the peak value. We say, what is the RMS value of sinusoidal AC? Peak value by root 2. What is the average value of sinusoidal AC in full cycle? That is 0. What is the average value of sinusoidal AC in half cycle? That is 2I0 by pi. Already discussed. Next. This is called full wave rectifier. Okay. So full wave rectifier means this one, this one, this one, this one. Okay. Here, current goes from 0 to maximum, then becomes 0, again 0 to maximum, 0, but current is positive only. Full wave rectifier is that device which converts alternating current into direct current. This we'll study in the semiconductors. Okay. And here, directly, guys, we don't have to prove it. The intelligent NEET student is one who remembers all of these things, because its derivation is not important at all. So directly remember this. If they ask you in the exam, you'll put up over there. We say for this full wave rectifier, if somebody asks you what is the IRMS value, so you say, sir, it will be I0 divided by root 2, peak by root 2 here also. If they ask you what is the average value in half cycle, here average value in half cycle is 2I0 by pi. Okay, in half cycle is 2I0 by pi, like the previous one, And what is the average value in full cycle? That is also 2I0 by pi. Why? Because the graph does not go down, but graph is in the positive, in the upper quadrant only. So if we say in this particular case, whatever is average for this, same will be for the full cycle. Okay, graph is exactly the same. Next. This is what we call the half wave rectifier. Half wave rectifier. Half wave rectifier is in which you get this as direct current. You get this positive cycle, then current becomes 0. Then you get positive cycle, then current becomes 0. This is what we call the half wave rectifier. And in this case, average current of half wave rectifier of this graph in half cycle is 2I0 by pi. It will remain the same. Okay. And when it comes to the full cycle, guys, here full cycle has got the average of I0 by pi. Why? Because the time is doubled over here. Guys, see, this is the graph, and then so we say time is doubled. This time plus this time is doubled, but this peak remains the same. That's why we say this is 2I0. It was 2I0 divided by 2. 2 and 2 will cancel. It will come out to be I0 by pi. Okay. And then we say we say IRMS value of half cycle. IRMS value, in this case, IRMS will be different for half cycle, IRMS will be different for full cycle. Here, IRMS in half cycle is I naught by root 2 and IRMS in full cycle is I naught by 2. Guys, this is the thing which you are supposed to remember directly. We cannot waste the time on such things. Okay, so directly, I say IRMS in half cycle, IRMS in full cycle. Average in half cycle, average in full cycle in case of half wave rectifier. Next, this is called square wave AC, which we have already discussed. Square wave AC. When it comes to these half wave rectifier, full wave rectifier, square wave AC, we don't have to do these derivations over here, my dear friends. Okay, we have to only focus on the derivation part of sinusoidal AC, because in our syllabus we have to discuss sinusoidal AC only. Okay, so we say here this is called square wave AC. Current is maximum and constant. Then it becomes negative, from negative side, maximum and constant. Okay, and here average in full cycle is 0, because the average in full cycle gets 0 for those currents if the amount of area from the upper side is equal to the amount of area from the lower side. This area is subtracted with this area, average is 0. Here also, this area, this is plus area, positive area, negative area, subtracted. In full cycle, average is 0. In full cycle, average is 0. And IRMS in this case is I naught only. That's what I was saying. If the current is constant, then its peak is same, its instantaneous will be that only, its average will be that only, its RMS will be that only. So its instantaneous is I naught, its peak is I naught, its RMS is I naught, its average is I naught. Everything will be same. So we say here IRMS in this particular cases, we say, sir, I naught. And when it comes to the average in half cycle, that is I naught, because for I naught, average will be there. For full cycle, it is 0. For half cycle, it will be I naught. Next, this is sawtooth AC. This is what we call the sawtooth AC. Okay, and in this particular case, you see, I average in half cycle, that is I naught by 2. I average in full cycle, that is 0. Why? Because the positive area from the upper side, negative area is exactly similar from the lower side. That's why in full cycle average is 0. In half cycle average is I naught by 2. Okay. Then I say IRMS in this particular case will be under root of, and that will be I naught by root 3 directly. Your IRMS will be I naught by root 3. Keep this thing in your mind. Next. Okay, this is an important question. It's a very good question actually. I want you to. Here is the old lecture enough. Old lecture is enough, but I would recommend you to watch this one. Okay, because some things I have added over here. Some things I have added over here. Now guys, find IRMS for full cycle. Now guys, see, here this is the current. For 0 to t by 4, current is 10 ampere. For t by 4 to t, current remains 0. You are supposed to find the IRMS. See guys, in this case, how to find the IRMS? Guys, we say IRMS means if you have a current, you basically do the square, then find the mean or average, then put the root. That is what we call the IRMS. Let's first do the square and find average first. Cool? Okay. Now, if I say here, guys. I say in order to find the average, what will we do? We say it is integration of I dt upon integration of dt. And we have to find the average from 0 to t. 0 to t. But we can write it something like this also. It is integration of I from 0 to t by 4, we'll split it from 0 to t by 4 dt plus integration of from t by 4 to t by 4 to t I dt. Once again, it's one and the same thing. If you find the average from here to here, from here to here, that's one and that's the average from 0 to capital T divided by integration of 0 to t. Here you'll keep the 0 to t only. Yes, sir. I can do it. I can do it. Not a problem. Now tell me one thing. What is the value of I from 0 to this? I is equal to 10 ampere from 0 to t by 4. No. Answer is not 10. Please. We are supposed to find the average in full cycle. Now, I can say, what is the value of I square? First do the squaring. So I square will be 10 square and that will be 100. Now, find the average. We say average of I square because then afterwards we'll put the root. That will be, we say integration of I square from 0 to t and then we say dt. Then we say plus integration of I square from t by 4 to t and then I'll write dt. And then I say integration of 0 to t and this will be dt. Now guys, tell me one thing. Can I write it something like this? This is I square is equal to, this is integration of I square dt. Guys, I want you to understand one thing. What is that? What is the value of I over here? I is 10. From 0 to t, value of I is 10. 10 square is, we say 100. So if we put 100 over here, take that out. Okay, or just put 100. Okay. And 0 to t, we say dt plus integration of, what is the value of I from t to this? So here I is equal to 0. So it will be 0 dt from t by 4 to t. Then we say integration of 0 to t dt. Now do the integration. Take this 100 out. So integration of dt will be t only. So it is t and the limits are 0 to t. Now this will become 0 only. Okay, leave it. Divided by integration of dt will be t only. Okay. From this is t from 0 to capital T. Okay, then next step. So this is t. Put this upper limit, so it will become 100 into capital T minus small t. That will be 100t. And here it is this t. Okay. Okay. 0 to t. Okay, I made a mistake. So this limit is from 0 to t by 4. Because 0 to t by 4, then t by 4 to t. 0 to t by, okay. This is 0 to t by 4. 0 to t by 4. So this is 0 to t by 4. Here. Now put the upper limit. This will be 100 into. Put this upper limit, that is t by 4 minus 0, that is t by 4. Upon this t. Now this t and this t will cancel. 100 by 4, it will come out to be 25. Yes, it will come out to be 25. Now, can I say, here, average of I square came out to be 25. Now apply the root. When you apply the root, it becomes IRMS. So it becomes IRMS. So it becomes I square, it becomes IRMS. So that will be under root of 25, that is 5. So 5 is the IRMS value from 0 to t by 4. But when it comes to 0 to, sorry, it is from 0 to t, IRMS is 5. When it comes to 0 to t by 4, sir, IRMS is 10 only. Even IRMS, average, peak, instantaneous, everything is 10 only. Because it's constant. Okay. And I'll mention over here. And from 0 to t by 4, IRMS is equal to I peak is equal to I average. Everything is 10 ampere. Give me the signal in the chat if everything is crystalline clear. if everything is crystalline clear. Tell me. Now guys, let's suppose I ask you something. Let's suppose I ask you something. What is that? What is that? See guys. That is, I say plot I is equal to I naught sine of omega t on the graph. Plot I is equal to I naught sine of omega t on the graph. Okay. You'll say, sir, it is simple. So when you have to plot the sinusoidal current, you'll say it is something like this. Let's call this as I1. This will be I1. Graph of sinusoidal current. And if I ask you, plot I2 is equal to I naught sine of omega t plus phi. I'm putting phi over here, initial phase. Okay, on the graph. You say, sir, I'll plot this also. No need to worry about this. When it is mentioned plus phi, means graph is starting from something else. Graph is starting from the maximum. Here, it is plus 0. Graph is starting from the origin. So here, graph will start something like this. It will be sine curve only. But here, graph is starting from plus phi. Phi can be anything. Plus 30 degrees, plus pi by 4, plus pi by 6. Okay. And this will be the graph of, we say, I2. I'm giving you the idea. What does this plus phi mean? Initial phase. From where the graph is starting. This gives you the idea graph is starting from 0, origin, because phi is 0 over there. Then I'm asking you the third question over here. Plot I3 is equal to I naught sine of omega t minus phi on the graph. Okay, so I can make it something like this. So it would be something like this, because it is starting from minus phi. So this is I3. This is I3. Okay. I3. Next, I am plotting all these three graphs on one single. Okay, I'm plotting all these three currents on one single graph. Now, guys, see, in this particular case, we said this graph which is starting from 0 will be I naught sine omega t. This graph which is starting from maximum will be I naught sine of omega t plus phi. This graph which is starting from minimum will be starting from I naught sine of omega t minus phi. Okay, and this was asked in IIT, by the way. Now, guys, this is plotting the currents on the graph. What if I ask you to plot these currents on the phasor diagram? Okay, representation of alternating currents and voltages on phasor diagram means plotting these graphs on the phasor diagram. We are supposed to plot these graphs on the phasor diagram. Okay, Now. What I'm asking you over here, plot these three currents on the phasor diagram. That's the question which I'm asking you over here. Plot these three currents on the phasor diagram. When it comes to the phasor diagram, guys, I want you to understand this. What does phasor diagram actually mean? See. We say, in case of a phasor diagram, we show currents or voltages with an arrow, like guys, see. We first and the foremost thing, whenever you have to plot the phasor diagram, you plot this kind of y-axis over here. Okay. Then you plot this kind of x-axis over here. Then you plot kind of x-axis over here. Okay, yes. And my dear friends, in this particular case, I want you to understand one thing. What is that? We say, when it comes to the phasor diagram, you make this as reference axis, and all this as sine of omega t. Like in the graph, this is x-axis, plus x minus x. Here I want you to remember, write sine omega t. And on this side, you write minus sine of omega t. Okay. Whatever I'm saying, please keep following. And right over here, this is cos omega t on this axis. And this is over here, minus cos omega t. Because this is 90 degrees. Sine of omega t plus pi by 2 plus 90 gives cos theta. Sine of theta plus sine of 90 plus theta is this. Okay. And this will be minus cos theta. Okay. Yes. Now, I'm giving you the current over here. I is equal to I naught sine of omega t. Okay. This is I1. I'm giving you the current I naught, we say sine of omega t plus phi. I'm giving you I3 is equal to I naught sine of omega t plus minus phi. Now guys, if only it is mentioned I naught sine omega t plus 0, nothing else, then you will be making the current on this axis. We'll be making the current on this plus axis. This is what we call I1. Okay. And if it is sine omega t plus something, plus phi, then guys, if it is plus, you move anti-clockwise. Go anti-clockwise. If it is minus, go in clockwise direction. So we say how much it is leading, it is plus phi. So you make this current something like this with the arrow. And I call this as I2. And this angle will be phi. So this will be simply, if it was sine omega t only, I would have made on this axis. It is sine omega t plus phi. So I can say it is I naught sine of omega t. Then we say plus phi. Okay. And then we say this is the another axis over here. And this is I3 is equal to I naught sine of omega t minus phi. This is phi. This is I naught sine of omega t minus phi. I naught sine of omega t minus phi. I naught sine of omega t minus phi. Okay. So if it was minus phi, you have to move clockwise. If it was plus phi, you have to move anti-clockwise. Okay. So if it was only sine omega t on this axis. Now, let's suppose I give you this question. Plot I is equal to 5 sine of omega t plus pi by 3 on the, what are you supposed to do? Make this axis, okay, and call this as sine omega t, and this will be cos omega t. This will be minus cos of omega t. This is minus sine of omega t. Now, it is 5 sine omega t plus pi by 3. Guys, if it was only sine omega t, I would have made on this axis. It is omega t plus something. So I'll make it something like this. So plus something is how much? This angle is pi by 3, or we say 60 degrees. And this current is, we say I. What is this 5? 5 will be the length of this arrow. Peak value, amplitude. 5 sine of, we say omega t plus we say pi by 3. Let's take a look on these currents. You have got the 7 currents. I would want you guys to plot all these 7 currents on this phasor diagram. Okay, this is a combination of 7 questions. I would want you guys to make on this phasor diagram. Okay. Now guys, tell me one thing. This is sine omega t. Okay, and what is this? This is cos omega t. What is this? This is minus sine omega t. And what is this? This is minus cos omega t. I can write it something like this. Okay. Now guys, tell me one thing over here. What is that? First is given over here 4 sine of omega t plus pi by 6. If it was only sine omega t, I would have made on x-axis. It is plus pi by 6. So I can make it something like this. I can make it something like this. Okay? Yes. Okay? Yes. And this angle is how much? It is plus pi by 6. So pi by 6 means 30 degrees. Okay? And I call this as I1. I call this as I1. I call this as I1. Okay? And its amplitude is how much? 4. Then you have second current. 5 cos omega t minus pi by 3. Guys, see. If it is only cos omega t, I'll make on this cos axis, cos omega t axis. But you can see it is minus pi by 3. Minus means you have to go clockwise. And plus means you have to go anti-clockwise. So I'll make this here something like this. This will be the second current. This is the first current and this will be the I2 second current. Sir, why did you make on this axis only? Why did you make on this axis only? Because it is minus pi by 3. Cos omega t minus pi by 3. Pi by 3 means how much? Pi by 3 means how much? 60 degrees. So if you go 60 degree in this direction, if you go 30 degree in this direction, so they will meet at the same point. Because total here is 90 degrees. So 60 plus 30 is 90. So 30 degree, 60 degrees. And this over I2. Why did I make I2 large? Because it has got the amplitude of 5. It has got the amplitude of 5. It has got the large amplitude. This will be I1 and I2. Then we say I3 is equal to 4 cos omega t minus pi by 2. I3 is what? 4 cos omega t minus pi by 2. Guys, it is cos omega t. Then it says minus pi by 2. Minus pi by 2 means minus 90 degrees. Cos omega t is along this. Minus 90 degree will be along this axis. So I say third current will be clearly along this. This will be I3. This will be the value of I3, I can say in this particular case. I believe this is getting crystal and clear. Okay. Then I4. 3 cos of omega t. So it is only cos omega t. So I'll make it on this axis. I'll make it on this axis. Okay. I'll make it on this axis because this is what we call I4. Then we say minus 4 sine omega t. This is plus sine omega t. From this side it is minus sine omega t. So I'll make it something like this. I'll make it something like this. Okay. This is I5. minus sine omega t. Then you have I6. This is 4 cos omega t plus pi by 3. Cos omega t plus pi by 3. Plus means anti-clockwise, minus means clockwise. So we say plus pi by 3, it would be something like this. Pi by 3 means how much? 60 degrees. So this will be I6 and this angle will be 60 degrees. Then minus sine omega t plus pi by 2. Guys. Minus sine omega t plus pi by 2. Plus means moving in the clockwise direction. Moving in the clockwise direction. Okay. Sorry, moving in anti-clockwise direction. So this is minus sine omega t. It is minus sine 7 sine omega t. Then plus pi by 2. Plus pi by 2 means 90 degrees. So don't you think this 7th current will be along this axis? So this will be I7. Please tell me in the chats how many of you understood this. Everyone means everyone. Tell me, guys. How many of you understood this properly? Give me the signal in the chats. And if you're not like the session, do hit the like button as soon as possible. Great. Next. Now guys, take a look. It says if the current I1 is equal to, here we have got current I1 is equal to, we say current I1 is equal to 3 ampere. It is 3 ampere. So I'll write directly 3 sine of omega t. And it says current I2 is equal to 4 cos of omega t. Find the net current. We are supposed to find the net current. Guys, we say draw the phasor diagram. In order to solve these types of questions, draw the phasor diagram. We say draw the phasor diagram. Draw the phasor diagram. Okay, yes. Now guys, how do we make the phasor diagram in this case? You have got 3 sine omega t, 4 cos omega t. Let's suppose if we make the phasor diagram, I'll directly make it with my hand. It is 3 sine omega t only in x-axis. Okay, so it would be something like this. I1, I call this as I1. Okay, and I'll mention its amplitude only. So I say I1 is equal to 3. I will mention its peak only. One and the same thing, because we know sine omega t is along this and this is peak. And I2 cos omega t, this will be, sir, along y-axis. That is I2 is equal to 4. Now if kind of one vector is 3, another is 4, could you please tell me what will be the resultant vector? We say if this is 3, this is 4, this will be 5. Resultant in this case will be 5. Okay. And how much will be this angle? How much will be this angle? Guys, listen. We say complete this triangle, complete, take this complete, make it a triangle. It would be something like this. This is 3, this is 5, and instead of this, I'll make it over here. This is 4. And this is the triangle in which this angle is 53 degrees, 3, 4, 5, 53 degree triangle. I have told you this many times. If one side is 3, this side is 3, this is 4, this is 5, then this angle would be 53. So I can say in this case, this angle is 53. Now guys, tell me one thing. First current has the peak value 3. Second current has the peak value 4. Net current has the peak value 5. Now, I'll just write equation of net current. Can I say equation of net current will be I is equal to I naught. What is the peak value of I naught? That is 5. And if it was along this, I would have mentioned sine omega t, but I'll write this is sine of omega t plus how much it is leading, that is by 53 degrees, sine of omega t plus 53 degrees. So this will be the value of net current over here, peak value and then how forward it is 53. So I'll mention it something like this question. You have got in this case I1 is equal to 3 sin omega t. You have got I2 is equal to 3 cos omega t plus pi by 6. And you are supposed to find the net current. Okay. Can we use the same approach by drawing what? The phasor diagram. So I say the simple thing over here is draw the phasor diagram. Okay. Now see. This current is 3 sin omega t, means it is something like this along x-axis. If it is sin omega t along positive x, if it is cos along y-axis, minus cos downwards, minus sine this negative x-axis. And how much is the amplitude? 3. So I can say I1 is 3. Cool. What is I2? 3 cos omega t plus pi by 6. Guys, if it was only cos omega t, I would have made along y-axis. But it is cos omega t plus pi by 6. Pi by 6 means how much? That is 30 degrees. So I can make it something like this. Okay, and this angle over here is 30 degrees, pi by 6. And this is I2. What is the value peak of I2? That is 3. I2 is equal to 3. Now, how much is this angle, bro? This angle is 90 degrees over here. 90 plus 30 is how much? 120. And in vectors we have studied, if a vector is, let's suppose this is F. Another vector is, we say, sir, F. Angle between the two vectors is 120. We say resultant in that case will be also F. Okay. And this angle will be 60 degrees if total angle is 120. So resultant will be at 60 degrees. So I can say in this case, if this is 3, this is 3. Angle is 120. Resultant will be also 3. And this angle will be 60. Yes, sir. Now write the equation of this. This is I net. This is I net. So can I say now, in this case, I net will be, what is the peak value? 3. So I'll write 3. And I can say this is sine omega t plus how much it is leading from sine omega t, that is 60 degrees. 60 degrees means pi by 3. So plus pi by 3. This is the equation. Or in terms of cos also we can write. This is cos. If this is 60, how much will be this angle? This will be 30. So we can write it something like this also. I say I net is equal to, peak is 3. Along this it is cos of omega t minus how much it is lagging from cos, 30 degrees. So it will be pi by 6 minus pi by 6. Either you can write sine omega t plus pi by 3 or you can write cos omega t minus pi by 6. One and the same thing. Give me the signal in the chats if this is crystal and clear. I want to know. Guys, tell me. Next, this one. What is the first thing we are supposed to do? Draw the phasor. I'll just write over here. Draw the phasor diagram. Yes, we'll draw the phasor diagram. I1 is 4 sine omega t minus pi by 6. 4 sine omega t minus pi by 6. Okay. Now I can say, guys. This is over here sine omega t. This is over here cos omega t. X-axis, y-axis. Sine omega t, cos omega t. Let me make it over here. This is sine omega t. And this will be cos omega t. Now tell me one thing. It is 4 sine omega t minus pi by 6. Sine omega t minus pi by 6. So I can say first vector would be something like this. This is I1. And how much is the value? This is 4. Then you have got, okay, one is, okay, cool. Pi by 6. And this angle is how much we say in this particular case? This is 30 degrees. Pi by 6 is 30. Then you have another one. I2 is equal to 4 cos omega t minus pi by 6. This is cos omega t. This is minus pi by 6. This is plus pi by 6. Minus something will be clockwise. Okay, and I'll make it something like this. Okay, I'll make it something like this. Okay, over here. And this angle will be how much? This angle is, we say, sir, pi by 6 means this is 30 degrees. So this will be 60. Let's do one thing. Let's change it a bit so that we'll get the good question. Omega t minus pi by 3. Let's call this as pi by 3. Let's make it pi by 3. So if this is pi by 3, cos omega t minus pi by 3. Minus pi by 3 will be how much? 60 degrees. So this angle is 60 degrees minus pi by 3. Then this angle will be how much? This is 30 degrees. And value of this I2, that is 4. Its value peak is 4. I hope you are getting crystal and clear. Okay. This I1 is 4, I2 is 4. Sin omega t minus 30 degrees, cos omega t minus 60 degrees. Okay. Okay. Now tell me one thing. If this is 4, this is 4. This is 30, this is 30. Okay. Guys, you might have studied, as I have told you this before. If you have got force F, angle between this F and F is, let's suppose, 60 degrees. Then we say resultant in that case will be a root 3F. Okay. Now, here. You have got 4. Don't you think that in this case, a resultant will be, net will be, that is 4 root 3? 100%, sir. Okay. Cos omega t minus pi by 3. See. Along this, it is cos omega t. If I say cos omega t plus pi by 3, so plus means clockwise. If I say cos omega t minus pi by 3 will be anti-clockwise. So this angle will be pi by 3. Pi by 3 means 60 degrees. So if this is 60, this will be how much? This will be 30 because total is 90. Rakesh, now is this clear? Now, so this will be 4 root 3. Now let's write the equation. Guys, don't you think this net current is along x-axis, along sin omega t? Yes. So I can say, so what is the net equation? That will be peak current 4 root 3. That will be peak current 4 root 3 sine of omega t. Sir, plus phi minus phi? No. Because it is along sine omega t only. That's why I'll keep it 4 root 3 sine omega t. Yes. Now, %65 to 70% of the chapter is done. Almost 70%. Okay. Okay. If the angle between the two vectors is 0 degrees, then this you simply add f1 plus f2, 2f. Resultant is 2f. 70% of the chapter is done. We have only 30% left and we'll finish that 30%. Okay. I think it will take 5 hours. We'll finish the chapter. Okay. Because after 3 hours, we take break. At 8 o'clock, we'll be taking the break exactly. So that's why I'm saying in 5 hours, we'll be finishing. So effectively, we are finishing the chapter in 4 hours only because approximately 1 hour we'll take the break. Now, guys, listen. AC source across pure resistance or pure resistive circuit. What does a pure resistive circuit mean? See. When it comes to a pure resistive circuit, see. Let's suppose you have got a resistance over here. You have got the resistance over here and you are connecting an AC source with it. Okay, this is the AC source. This is the resistance. Is there any other load, any other element which is present in the circuit? No. You have got only resistance and AC source. This is considered and this is what we call the pure resistive circuit, or AC source across pure resistance, no other thing, no capacitor, no inductor. Okay, and we say EMF of this is, let's suppose, E naught sine of omega t, because since this is the alternating source, we mentioned the EMF something like this, not 20 volt, 30 volt, something like this. This is the peak voltage. Okay, and sir, since this battery is connected to the resistance, it will give to the potential difference to it. That will be, this is VR. Potential difference across the resistance is VR. Okay, yes. So we say, let the potential difference across the resistance is VR. Let the potential difference across the resistance is VR. Cool? Yes. Now guys, listen to me very carefully. We know that this battery, this alternating source, will send the alternating current. Let's find the current in the circuit. Let's find the current in the circuit. Okay. So when it comes to the current in the circuit, guys, understand one thing very carefully. When it comes to the current in the circuit, if you want to find the current in the circuit, what will you do? Is that we say, as current is simply, that is V divided by R, where R is the resistance, because V is equal to IR and I is equal to V by R. Okay. So now tell me guys, in this case, can I write this current will be, what is the value of V? Guys. We say here, potential difference across this resistance. This battery will give the potential difference to it. If we have studied previously, this is the resistance and this is the battery. If this is 20 volts, we said this 20 volts will be completely given to the resistance, because only this resistance is connected to the load. So across this potential difference is 20 volts. If I say you have one resistance, another resistance, in this case, let's suppose this is 20 volts. We say maybe this will take 10. If this takes 10, so 10 will be divided here. 10 plus 10 is 20. But if there is only one resistance, all the EMF of the battery is given to this. So we say here, as VR is equal to E naught sine of omega t. Now tell me here. So I can write, when it comes to the current, we say, instead of V, I can write, we say E naught sine of omega t, and divided by, we say, R. What is this E naught? E naught is the peak voltage. Peak voltage divided by peak resistance. V by R, voltage by resistance is current. Peak voltage by peak resistance is peak current. So I can say I is equal to I naught sine of omega t. I can say I is equal to I naught sine of omega t. Okay. Now guys, plot I and VR on the phasor diagram. Guys, see. We say this VR is E naught sine omega t. Okay, this VR is E naught sine omega t. So I'll make it something like this along x-axis. This is VR. Positive, because this is sine omega t, cos omega t, minus sine, minus cos. So it'll be along positive x-axis. And don't you think in this particular case, this current, this will be also along positive x-axis. This is I. This is VR and this is current. VR and current. Now, sure. Can I say here in pure resistive circuit, in pure resistive circuit, this VR and I, VR and I are in the same phase. Same phase. Same phase means they are parallel to each other. Their phase difference is 0. Phi is 0. They are along. If this is along sine x, this is along sine x. They are parallel to each other. Okay? Cool? Yes, yes, yes. This is what I wanted to show. Next. AC source across pure inductor. Let's suppose we have got an inductor over here. This is how we make inductor. Okay? And then you connect an AC source with this inductor. And in this case, the EMF of this inductor is E naught sine of omega t. E naught sine of omega t. And potential difference across this is VL. Previously we said VR, here it is VL. Okay. Now guys, in this particular case, let's find the current in the circuit. Like previously we calculated the current in this circuit. Similarly, we are finding the current in this circuit now. I would want you guys to find the current in this circuit. Okay. I would want you guys to find the current in this circuit. Okay. And this is called pure inductive circuit. Why? Because only inductor is connected to the AC source. That's the reason we are calling this as pure inductive circuit. Now see, we say as, listen to me very carefully. Guys. Here, in the previous case, you say V is equal to I into R. Here we say, here as in inductor, can I say this VL will be equal to, that is E naught sine of omega t. Why? Because this battery is directly connected to this load. So whatever is the potential difference EMF of this battery, that will be given to the inductor. And also we know in previous marathon I have told you potential difference across inductor, it is V is equal to L di divided by dt. This is how we find the potential difference across the inductor. V is equal to L di by dt. Now guys, take it over here. So this will be L di is equal to, we say, V dt. Okay. Now we say do the integration from both sides. Okay. Do the integration. Or integrate both sides. Now we say this will be integration of LDI is equal to integration of VDT. Because here, guys, you write V is equal to IR. In case of inductor, you write V is equal to LDI by dt. This is how we find the potential difference over here. Now, L is constant. Okay, take this out. So it is integration of di is equal to integration of. Instead of this V, we can write this is E naught sine of omega t, and then we say dt. Now, guys, listen to me very carefully. This peak will come out. Okay, peak will come out of the integration. So we say this and this will cancel. So L into I is equal to. So peak will come out of the integration. Then it is integration of sine omega t. What is integration of sine omega t? That is minus cos of omega t. Okay, divided by omega. Whatever is in the angle over here, that is divided. Coefficient will be divided over here. Okay, cool. Now. Guys, take this L over here. We say I is equal to, this will be E naught, and take this negative sign out. Minus, we say E naught divided by this omega, this L, and then you say cos of omega t. Okay. Now, put omega into L is equal to XL. Sir, what is this XL? Replace this omega L with the XL, where XL is called inductive. XL is called inductive reactance. Where XL is called inductive reactance. What is inductive reactance? We say it is the resistance in case of the inductor. Sir, does inductor also has the resistance? Yes. So the resistance of inductor is called the inductive reactance, where XL is called inductive reactance and behaves like a resistance in case of an inductor. Okay, in case of an inductor. Okay, now from this equation, I can write I is equal to, we say, E naught divided by XL minus E naught by XL cos of omega t. Guys, peak voltage divided by resistance. Sir, this is resistance. Yes. Inductive reactance is also resistance in case of the inductor. So peak voltage by resistance, V by R. So this is what we call the peak current, I naught, and minus I naught cos of omega t. This is the current that we got exactly over here. This is the current that we got exactly over here. And you write over here where I naught is equal to E naught divided by XL. Now I am asking you the question. Let me write it over here. We say plot VL and I on the phasor diagram. Guys, you see over here, what is the value of VL? E naught sine omega t. What is the value of I? Minus I naught cos omega t. We say as VL is equal to E naught sine of omega t and I is equal to minus I naught cos of omega t. Don't you think that in this particular case, this is along x-axis. This is I. And plus cos omega t is along y-axis, plus y-axis. Minus cos will be downwards. Okay, minus cos will be downwards. So this is VL. Sorry. This will be VL. This will be VL and this will be, sir, I. Because this is minus cos omega t. Current is downwards. This is something like this. Can I say here, in pure inductive circuit, we say voltage lags current by pi by 2. Voltage lags current by pi by 2, or you can also say voltage leads current by pi by 2. Your voltage leads current by pi by 2. Or we say current lags, current is behind voltage, current lags voltage by pi by 2. Even you can make it something like this also. Guys. If you make this VL along y-axis, then current should be something like this. This is current. Because here also, current lags voltage by pi by 2. Even you can make it something like this also. If this voltage is something like this, VL, this will be the current, that is I. Here also, voltage leads current by pi by 2. It's one and the same thing. So in whatever way you want to make it, but make sure voltage should lead current by pi by 2. Okay. Then you have got AC source across the pure capacitance. AC source across the pure capacitance, pure capacitive circuit. So you have this battery. Okay, you have this battery in this case, and you have connected a capacitor over here. You have a battery and connected a capacitor over here. Okay, you have a battery, and why am I making this? See. You have a capacitor and you have an AC source. You have a capacitor, you have an AC source. So E is equal to E naught sine of omega t. And potential difference across this is VC. Potential difference across this is VC. Okay. Now guys, we say let's find current here. Like previously we calculate the current here also. We say as potential difference across capacitor will be exactly equal to E naught sine of omega t. Why, sir? Why, sir? Because the potential difference of the battery is directly given to the capacitor because it's directly connected. And then, ladies and gentlemen, boys and girls, this is VC is equal to E naught sine of omega t. E is equal to E naught sine of omega t. Yes. Cool. Clear. Now tell me, we say as when it comes to the capacitor, we say V is equal to Q divided by C. Guys, remember very properly. In case of inductor, we used L di by dt. V is equal to L di by dt. In case of resistor, we use V is equal to IR. And here, we will be using V is equal to Q by C. Basic equation of the capacitor. Now, tell me one thing. Tell me one thing over here. Can I say, sir, this Q divided by C will be equal to, sir, this. What is the value of V? E naught. And then we say sine of omega t. Multiply it over here. So Q will come out to be E naught into C sine of omega t. Now you got the value of charge. If you know the value of charge, you want to find the current. What are you supposed to do? You will have to differentiate. We say differentiate Q with respect to time. So can I say that will be dq divided by dt, differentiating both sides. It will be d by dt of from this side differentiation of this one. That will be E naught into C. That is sine of omega t. Yes. I believe so. Now what is dq by dt? Sir, it is current is equal to. And what is this? Sir, E naught will come out, C will come out. Both are constants, capacitance and E naught. So C E naught will come out. Then we said differentiation of sine omega t is what? That is cos omega t. And then this omega, differentiation of this omega t, that will be omega. This is called the chain rule of differentiation. If it is sine of 2x, what is the differentiation of sine of 2x? Cos of 2x into 2. Sine omega t, differentiation of sine omega t, cos omega t into omega. Now take it over here. We say current will come out to be C omega, or write it something like this, omega C E naught cos of omega t. Now I want you to take these in the denominator. Okay, so I can write I is equal to, so this will be E naught divided by 1 upon omega C, because if you take once again in numerator, it will become omega C into E naught. Then we say cos of omega t. Then we say cos of omega t. Now we say here, or we say replace 1 by omega c with xc. I want you to replace this 1 by omega c with xc, where xc is called capacitive reactance. Like you have inductive reactance, here it is capacitive reactance. Sir, what is capacitive reactance? Capacitive reactance is the resistance in case of a capacitor, which itself is the resistance in case of a capacitor, which itself is the resistance in case of a capacitor. Okay, now guys, can I say, so I can write over here, this is I is equal to E naught divided by XC, E naught divided by XC, and then I can say cos of omega t. Now what is this peak voltage divided by resistance? That is current, peak current. So I will be equal to I naught, and we say cos of omega t. I will be equal to I naught, then we say cos of omega t. Where this is what we call the, we say where I naught is equal to A naught divided by X. This is the current and this is the, this is the voltage. Now here also I want you to plot VC and I on the phasor diagram. On the phasor diagram. Plot VC and I on the phasor diagram. Plot VC and I on the phasor diagram. Now guys, tell me one thing. We say as VC is equal to E naught sine of omega t, and I is equal to I naught cos of omega t. Can I say in this particular case, guys, this will be current along cos omega t, this is current, and this will be VC. And how much is the angle? Pi by 2. And tell me which one is leading, which one is lagging. Current leads voltage by pi by 2. We say here I leads VC, we say by pi by 2, and VC lags I by pi by 2. Even we can make it something like this, guys. If you make current along forward direction, something like this, okay, then I can say this will be VC, because current should lead voltage by pi by 2. You can make it something like this. So phi in this case is pi by 2. Phi in this case is pi by 2. Okay, cool. Done with all the three capacitors, all the three circuits. Now you have all of this detail I was explaining till now. It is only because of LCR circuit. Because if I take directly LCR without making you understand pure capacitor, pure inductor, pure resistor, then LCR would be very difficult for you to understand. Now it becomes very easy. What is LCR? We say that circuit in which all the three are present. L means inductor, R means resistor, C means capacitor. LCR circuit. Okay. Now guys, understand one thing. What is that? Break will be exactly at 8 o'clock. Let's make the LCR. So we say this is L, we say this is C, and we say this is R. And then connect an AC source to it. Now guys, I want you to understand one thing. What is that? We say This is E is equal to, or I'll write over here, V is equal to V naught sine of omega t. I can write it something like this. And potential difference across this is Vc. Potential difference, sorry, this is VL. This is VL. Potential difference across this is Vc. Potential difference across this is VR. This is resistance, this is capacitance, and this is inductance. LCR. Okay. Yes. Now, first and the foremost thing is, let's suppose if I say current coming from this is, we say I, and this will be the alternating current. First and the foremost thing is, in case of LCR, we say plot the phasor diagram. Phasor diagram. As tell me, you have VL, VC, VR, and you have current I. Let's suppose if I make the current in the forward direction, this is current I. Could you please tell me, where am I supposed to make VR? We say potential difference in case of the resistance is along current only. Both are in the same phase. Current and potential difference in case of resistance are in the same phase. In case of inductor, voltage leads current by pi by 2. In case of an inductor, we say capacitor, voltage lags current by pi by 2. Let's make over here. We say voltage in case of resistance will be along current only. Yes, we completely agree with you, sir. Then you have got voltage in case of inductor, that is VL. Then you have got voltage in case of capacitor, that is VC. So this VC lags current by pi by 2. VR is along, VL leads current by pi by 2. I hope this is crystal and clear, this phasor diagram. Now. If I say, if VL is greater than VC, by any chance, if this VL came out to be greater than VC, if VL is greater than VC, how are we supposed to make the diagram? Sir, this factor minus this factor. So we say, we can write in that case, this will be VL minus VC. And this will be over here, this is VR. And current will be along this only, okay? Now this and this factor, they have got, we say the resultant something like this. This will be the V net. See. What I'm trying to say is that, if you make the phasor diagram, we say VR, potential difference across the resistance, and current will be in the same phase. Why? Because we studied this. Potential difference across the capacitor will lag current by pi by 2. Potential difference across the inductor will lead by pi by 2. That's what I'm saying. If I say this case, the value of this came out to be greater than this, the net will be upper minus lower, and direction is upper. Okay, and this is VR. Now resultant of this one and this one will be V net. And could you please tell me what is the value of this V net? It is very simple, sir. This factor square plus this factor square. So that will be under root of VR square plus, we say VL minus VC whole square. Okay, crystal and clear. Next. If I am saying, if, let's suppose VC is greater than VL. If this voltage is greater than VL, in that case, you make the diagram something like this. This will be VC minus VL. Lower minus upper, and this will be VR, and this will be current I. Here, net voltage will be in this direction, this is V net. And how am I supposed to find the value of V net? We say V net in this case will be under root of, that is VR whole square plus VL minus VC whole square. Okay, cool. Now guys, I hope this is crystal and clear. Now let's do one thing. Let's make the impedance diagram. Next is, let's make the impedance diagram. in LCR. What is impedance diagram? Impedance diagram is exactly the similar diagram, but over there we mention what the resistance is. See guys. I'll copy that diagram only. So we say this is VR, this is VL, and this is VC, and this is current I. Now guys, can I say, sir, this VR, we say V is equal to I into R, potential difference across resistances I into R. So can I say instead of this VR, I'll be writing over here current into resistance I into R. And then, sir, this VL, instead of this VL, we can say, sir, V is equal to current multiplied by resistance of inductor. What is the resistance of inductor? That is XL, because recently you studied. XL is the resistance in case of inductor. So I into XL will be this. Okay. Now I can remove this and I can write over here current and its resistance, that is XL. Here current into this resistance. And in this case, can I write current multiplied by its resistance, that is XC. Because capacitive reactance XC is that resistance which is for capacitor. This is for inductor. Okay. This is called the impedance diagram. Okay. Now, this I is same in all. So I want you to remove this I also. No need to mention this I will cancel. So this will be XL. This will be R. And this is XC. So in case of the impedance diagram, we only mention the resistances. Okay, we mention resistances only. Now guys, see, one more thing. If I say, if we say XL is greater than XC, let's suppose by any chance resistance of this is greater than resistance of this, means XL is greater than XC, then we say, then LCR is inductive in nature. Then we say LCR is inductive in nature. Yes. Now, can I say in that particular case, guys, this is XL minus XC. In that case, we can say net will be XL minus XC. And in the forward direction, I can say this will be resistance R and this will be the current I. Now, guys, here we say net resistance of this resistance and this resistance will be something like this. And that is what we call Z. And Z is what we call the impedance. So we say this Z is the net resistance. Can I say this will be under root of this vector square plus this vector square? That is R square plus, because this is how we find the resultant of two vectors. That is XL minus XC whole square, where Z is called impedance, and is the resistance of LCR circuit. Guys, if I say a resistor has got what resistance? R resistance. Capacitor has got what resistance? XC. Inductor has got what resistance? XL. LCR has got what resistance? Z. Z is the impedance. Impedance is the resistance of LCR. And second, and then one more thing over here. Let's suppose this angle is phi. This angle is phi. Can I say this tan of phi will be equal to what? Guys, this is perpendicular. Take it over here. Now this triangle, perpendicular. This perpendicular by base. So perpendicular will be what? XL minus XC. And base will be what? That is R. This is how we find the tan of phi also. Next. We say if XC is greater than XL, then LCR is capacitive in nature. Capacitive in nature. Then LCR is capacitive in nature. Guys, see, means if this XC is greater than XL, then in that case, we say the resultant diagram would be something like this. This will be R, this will be XC minus XL, and this is the current, something like this. Now here, impedance will be resultant of this one and this one. This will be the impedance Z. And this Z in this case will be under root of, we say, R square plus XC minus XL whole square. And in this case, this angle would be phi. So we can say here, this tan of phi will be simply this perpendicular divided by this base. That is XC minus XL divided by base is what? Base is XC minus XL divided by R. XC minus XL divided by R. Okay. So this is the complete detail about LCR circuit. And one more thing. If you ever see, we say RL circuit. If you ever see LC circuit, okay, RL, LC. If you ever see RC circuit. Sir, what does this mean? This means it is that circuit in which inductor and resistor is present and an AC source. This is that circuit in which inductor and capacitor is present, L and C, and an AC source. This is that circuit in which a resistor and a capacitor is present. Okay, this is RC source. This is RC circuit. Now, guys, we say, here, could you please tell me, can you make the impedance diagram, phasor diagram, and in this case, 100%, sir. Here it is, this is VL and this will be R. Here this is VL and this is VC. Here this is VL, VR, and this is C. Okay. So in a similar way, when you have, let's suppose you have VL and R. So VL will be along this direction, potential difference across this. Okay. And this is VL and this will be VR. Potential difference across. If this is current and VR are in the same phase, this will lead by pi by 2. This will be phi. Now, resultant of this one and this one will be V net, something like this. And if we make the impedance diagram will be, this is XL, this will be R. So this will be the impedance Z. So that will be under root of this XL square plus R square. And this will be phi. And tan of phi in this case is, we say, sir, perpendicular. Perpendicular is what? That is XL divided by R. So if you are able to understand, if you understood this series LCR, whether whatever I give over there, RC, LC, you would be able to solve every question. That is for sure. So we are done with LCR circuit. Now, how much is left? Okay. We have some questions. Okay, let me see. Guys, smash the like button if you have not liked the session yet. Now guys, let's talk about this particular question, and this is the question which is which is, we say, the killer question of the today's session, which is extremely beautiful, extremely important. I would say this is very important. And this question itself is the combination of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions. Okay. These, forget about these two as of now, because we will see this after some time. So rest of the 9 questions, this is the combination of 9 questions. Okay. So you are given an LCR circuit. You have to find the value of XL, inductive reactance, capacitive reactance, impedance, phi, angle phi, V naught, peak value, peak voltage, VT, a VR of T. I'll show you all of these. See, guys. Here, current in this case is given as I is equal to, we say, 10. Then we say sine of 100t. 10 sine of 100t. Okay. And in this compare with, I'll say compare with. I is equal to, we say, I naught sine of, we say, 100t. I is equal to I naught sine of 100t. I would want you guys to compare it with this one. Now, guys, I say here I naught is equal to, we say, 10. Here I naught is equal to 10. And in this particular case, sir, I naught is the peak current, and omega, I naught omega t. And omega in this particular case is, we say, 100. I naught sine of omega t. Let's first find the value of XL. We say first. Okay. We say XL in this particular case will be omega into L, because we know when it comes to the XL, it is omega into L. And what is the value of omega? Omega is given as 100. And what is the value of L? L is given as 0.16. So 100 and 0.16 is 16 ohms. Since I told you this is the resistance, its unit is ohms. So it will be 16 ohms. Okay. Then we have next XC. What is the value of XC? 1 upon omega C. So I can say this will be 1 upon, what is the value of omega? Omega is 100. Okay. And what is the value of C? C is given as 500 microfarad in this particular case. Okay. Okay. So I can say this will be 500, okay, multiplied by 10 raised power minus 6. Because it's in the microfarad. If you convert to the farad, multiply with 10 raised power minus 6. Okay. Yes. Now, solve it. Omega C will come out to be, that is 20 ohms. Omega C will come out to be 20 ohms. Okay. Yes, sir. Now, you got the value of XC, you got the value of XL. Tell me one thing in this LCR. Is XC more or XL more? We can clearly see here XC is greater than XL. We can say here XC is greater than XL. So LCR is capacitive in nature. Capacitive in nature. LCR is capacitive in nature. And when the LCR is capacitive in nature, can I say in that particular case, guys, this will be XC minus XL. This XC is greater than XL. This will be, sir, R. And this is the current I. This will be, in this case, impedance Z. You can clearly see when LCR is capacitive in nature, this is XC minus XL, this is R, this is Z. And value of Z is this. Value of impedance is this. So I say in this case, we say Z is equal to, that is under root of R square plus XC minus XL whole square. So Z is equal to, what is the value of R? R is given as 3 square plus XC minus XL. XC is 20 minus 16, that is 4 square. So 4 square is 16. 3 square is 9. 16 plus 9 is 25. Root 25. Z will come out to be 5. Z will come out to be 5. And what is the value of this angle over here? This is phi. So let's find the value of tan phi. We can say tan phi in this case is, guys, this, take this vector over here, this will become triangle. So perpendicular by base, tan phi is perpendicular by base. That will be xc minus xl divided by, we say, r. So I can say over here tan phi will be, what is the value of xc minus xl? xc is 20 minus 16, that is 4. And what is the value of r? That is 3. When is the value of tan phi as 4 by 3? Guys, take a look at this 53-degree angle triangle. In case of 53-degree triangle, we say this side is 4, this side is 3, this side is 5. Tell me tan 4 by 3. We say tan 53. Tan of 53 will be equal to 4 by 3. Perpendicular by base. So phi is 53 degrees. Phi is 53 degrees. Okay, phi is 53 degrees. Now, in this case, you got the value of phi also. This is done, this is done, this is done, this is done. Now V naught. Guys, when it comes to the V naught, we say peak voltage is equal to peak current multiplied by net resistance. So net resistance of this circuit is Z, impedance. Peak current is how much? I naught. What is I naught? That is this. So when you multiply peak current with net resistance, you'll get peak current. So I can say V naught is equal to, we say I naught is 10. And what is the value of Z over here? Z is 5. Z is 5. So V naught will come out to be 50 volts. So peak voltage is 50 volts. Cool. Now guys, you got it, Now from this impedance diagram, let's make phasor diagram. Let's make phasor diagram. Okay. Now guys, when it comes to the phasor diagram, we say this is XL minus XC. So I can say this will be VC minus VL. And in the forward direction, this will be VR. And this is, we say, sir, current VL. Sorry, this is the current I. Okay. And we say this will be the value of net voltage. Okay. And this angle is phi over here. I'm copying exactly over here. So this is VR, VC minus VL, this is V net, and this is phi. So this phi came out to be 53 degrees. Now, let's write the equation of voltage, net voltage. I'll show you over here. Let's write the equation of net voltage. That is V of t. Guys, understand one thing very carefully. We know equation of current is, we say as equation of current I of t is equal to how much? 10 sine of 100t. 10 sine of 100t. Don't you think that in this case, this current is something like this? And this net voltage is lagging current by how much? 53 degrees. So whatever is the value of current, same will be for voltage, but minus 53 degrees. So I can say this V lags I by 53 degrees. So I can say from now in this, so I'll just write over here, V of t will be simply I of t. This is I naught peak current. Here I'll just write peak voltage V naught. And then I'll say sine of same. This is sine of 100t. Just I'll write over here minus 53 degrees. Why? Because net voltage is lagging current by how much? By 53 degrees. That's why I'm making minus 53 degrees. And what is the value of peak voltage? Peak voltage we got as 50 volts. I'll say V of t is equal to 50. Then I say sine of 100t minus 53 degrees. I hope you got it. Okay. And then guys, look at this. See. let's write the equation of VR of t. Let's write the equation of VR of t. What is VR of t? VR of t is voltage in case of resistance. Let's write the equation of VR of t, voltage in case of resistance. Guys, see the original phasor diagram in case of LCR. This will be VR, this will be VL, this will be VC, and this is the current I. Don't you think that VR and I both are in the same phase? So whatever is the current for current, whatever is the equation for current, same will be for VR. So we say as VR and I are in the same phase. So can I say, guys, can I say VR of t, voltage in case of resistance with time, this will be simply that is peak voltage in case of resistance. This is peak voltage in case of LCR, peak voltage in case of resistance, and then copy this sine of 100t. Whatever is the equation of current, same will be for voltage. Just here it is peak voltage. And how do we find the peak voltage? Peak voltage will be peak current multiplied by resistance. If you're talking about resistance, then multiply with resistance. Then we say sine of 100t. What is peak current? That is 10. And what is the resistance given over here? Resistance of this is given as 3 ohms. So I can say this will be 10 into 3 sine of 100t. So that will be 30 sine of 100. Now let's write the equation. Now let's write the equation of VL of t. Guys, VL leads current by pi by 2. So I can say VL of t will be simply, here it is peak voltage in resistance. Here I write peak voltage in inductance. Then I'll write sine of 100t. This is the equation of current. Then we say plus 90 because it is leading by plus pi by 2, plus 90. Now how to find this V naught of this? So you can say this will be I naught into XL, peak voltage into peak resistance. So I can say sine of 100t plus we say pi by 2. So what is I naught over here? Guys, what is I naught? I naught is 10. Okay, this is 10. And XL is 16. We already got it. XL is 16, you see over there. Okay. And this will be sine of 100t plus pi by 2. So this will come out to be 160 sine of 100t plus pi by 2. Okay. Next we have got let's write the equation of VC of t. So we say VC of t will be simply, that is peak voltage in case of capacitor. Then we say sine of 100t. Guys, peak voltage in case of capacitor lags current by pi by 2. So whatever is the equation for current, just minus pi by 2. So I say it is minus pi by 2. Simple. Reference you are taking over here, current. So I can say this will be I naught into XC, peak voltage into capacitive reactance. Then I'll write over here sine of 100t minus pi by 2. So what is the value of peak voltage over here? Peak voltage in this case is, that is 50. Sorry, I naught is 10 into 20. So this is 10 and this is 20. X is 20. Sine of 100t minus pi by 2. So this will come out to be 200 sine of 100t minus pi by 2. Guys, is this crystalline clear? So we have solved all the questions of this. We have solved all the questions of this. This was a combination of 9 questions. This is done, this is done, this is done, this is done. Apart from these two, we'll have to study these two first. So let's take a break. Break. What is the time right now? It's 8:04. So break is till 8:50. Okay, this is a long dinner break. After break, we'll meet, and after break, it will take us only 1 hour, even less than 1 hour. Okay. So see you guys after the break. Check. Let's start once again. Okay. Let's dive into the session. So. Okay. I hope everybody has joined once again. Let's wait for a minute and we'll start. Okay. Take a look at this question, guys. Take a look at this question. Take a look at this question. Here you have got resistance and as 300. Okay. Okay. Now, guys, let's take a look at this particular question. We have got LCR once again. And right now we are given the equation of voltage. V is equal to 50 sine of 100t plus 30 degrees. And we are supposed to find XL, XC, Z, phi, I naught, I of t, all of these. Okay. First and the foremost thing is, guys, if we compare this with V naught sine omega t, can I say over here clearly in this particular case, we can say V naught is given as 50 volts. Okay. V naught is given as 50 volts. And when it comes to the omega in this case is given as 100 sine omega t. Omega is given as 100. Now guys, in this particular case, I would want you to listen to me. When it comes to the XL, the very first thing, that is XL. XL will be simply, that is omega into L. So I can say XL will be simply, what is the value of omega? That is 100. And what is the value of L over here? L is given as 1 because L is 100. So it will come out to be 100 ohms. And then we talk about XC. What is the value of XC? That will be 1 upon omega C. This is how we find XC. And I can say in this particular case, this is 1 upon omega is 100. And this is 20 microfarad. So this will be 20 into 10 raised power minus 6. And if you solve this, XC will come out to be, that is 500 ohms. XC will come out to be 500 ohms. Now, clearly in this particular case, here, I can say here, XC is greater than XL. I say XC is greater than XL. If XC is greater than XL, then we say circuit is capacitive in nature. Circuit is capacitive in nature. If XL is greater than XC, we say circuit is capacitive in nature. Absolutely clear. Now guys, when the circuit is capacitive in nature, let me just tell you over here, we say, what will be the value of impedance? What will be the value of impedance? Sir, this is R. In that case, this will come out to be XC minus XL, XC minus XL. And impedance would be something like this. Okay. And how do we find this impedance? We can say this impedance will be under root of, we say R square plus XC minus XL whole square. This is how we are supposed to find the impedance over here. Okay. This is how we are supposed to find the impedance over here. And this will be phi. Because if circuit is capacitive in nature, we say this resistor will be greater than this resistor. This resistor will be greater than this resistor. Okay. Then we say this resistor, this resistance will be greater than up, lower one greater than upper. So I can say Z in this case will be, what is R over here? R is given as 300 square plus XC minus XL. That is, XC is given as 500, XC is 500, XL is 100. So it will be 500 minus 100 whole square. So it'll be 500 minus 100 whole square. That will be 400 square. And Z here will come out to be, that is 500. Solve this, it will be 500 ohms. We got the value of impedance also. What is happening with this? Okay. Now, if we got the value of impedance, can we find the value of phi also? We can, sir, tan of phi in this case will be simply, that is perpendicular by base. Perpendicular is this, that is XC minus XL divided by resistance. And tan of phi, what is XC minus XL? You say, sir, that will be simply, XC is 500 minus 100, that will be 400 divided by 300. This and this will cancel, it is 4 by 3. Again, tan phi came out to be 4 by 3. We say phi will be 53 degree once again. So this is 53 degrees. So we got the value of these four. Let's find the value of I naught. Let's find the value of I naught. When it comes to the value of I naught, we say as peak value I naught is V naught divided by Z. Peak voltage by resistance, impedance. So I naught is, what is the value of V naught that we got over here? V naught is given as 50 volts, okay? And we say this is 50 divided by Z is 500, okay? So this will come out to be 0.1 ampere. So I naught came out to be 0.1 ampere. Cool? Yes, sir. Now let's find the equation of current. Guys. If I just make over here, I would want you guys to understand one thing. We say, sure, this is the phasor diagram. This will be the phasor diagram of capacitive circuit, capacitive in nature, okay? We say this is V, this is, I'll make it something like this. This is over here, this is VL, VC minus VL, okay, VC minus VL. This is VR, okay, and this is current I, and this will be over here net voltage. This is net voltage, okay, because from this impedance diagram, I'm exactly copying this diagram. And this value is over here, phi is equal to 53 degrees. Now, this is the net voltage. Guys, if this is the net voltage, I want you to understand one thing. What is this? This voltage only is divided into this, and this. So net voltage is given as this. This is the net voltage of the circuit. It is only divided. So we say this is net voltage of the circuit. So it is given over here. Its equation is given. We say it is given as, that is 50. We say sine of, 50 sine of 100t plus 30 degrees. 100t plus 30 degrees. This is the equation of this. Previously, in the previous question, you were taking the reference as current. Here, this is given. Take this as reference. Now, tell me one thing, guys. We say this current lags this voltage, okay? Sorry, leads voltage. This leads this voltage. By how much? By 53 degrees. I leads this. This voltage is something like this. It leads it by 53 degrees. So we say I leads V net by, we say 53 degrees, because it is 53 degree in lead. So can I say in this particular case, we say equation of current will be, I of t will be, sir, I naught is the peak voltage. Here it is V naught, here it is I naught. Then I'll write same equation, sine of, we say 100t plus 30 degrees. Sir, it means right now current is along this, but it is leading by 53. So you say it is plus 53 degrees. Because it is 53 forward. Whatever is the current equation of this voltage, you write same over here. Just do the plus 53. Now, I naught you recently got. What is the value of I naught? What is the value of I naught? Okay, you didn't get that. Okay, I naught, we got it over here. That is 0.1. So this will be 0.1 sine of, we say 100t plus 53 plus 30 is 83 degrees. I hope you got the value of this. I hope you understood this. Okay. Now guys, let's take a look. So let's make this diagram. This is originally VL, this is originally VC, and this is originally VR. This is what we say current I, and this is what we say V net in this particular case. This angle is given as 53 degrees. Now tell me. Guys, see. This is V net. How much is this VL in lead from this V net? Or how much is VR in lead from this? Guys, we say VR leads V net by 53 degrees. So let me write the equation of VR. So VR of T will be simply peak voltage V naught. Then we say whatever is the equation for this one. So V naught of R, that is peak voltage in resistance. Then I'll write sine of, we say 100t plus and how much? 100t plus 30 plus 53 degrees. Why? Because this leads this V net by 53 degrees only. Hey bro, whatever is the equation for current, same will be for VR because they are along. So this VR leads this V net by 53 degrees. So write the same equation over here, but just add plus 53 degrees. So I can say VR in this case will come out to be V naught of R. So I can say this will be I naught into R. Then I can say sine of 100t plus 53 plus this will be 83 degrees. And what is the value of I naught? 0.1. And what is the value of this R? R is given as 300. Okay. Sine of 100t plus 83 degrees. So this will come out to be 30 sine of 100t plus 83 degrees. I hope you got it. This is VR of T. And similarly, if we write over here, guys, see. This VL leads this V net by how much? Sir, 53 plus 90. If I write the equation of VL, guys, I'll write equation of VL of T. That will be simply peak voltage in case of inductor. Then I'll write sine of 100t plus 30 degree. Then we say plus. Right now, this is the equation of net. How much I should add? 53 plus 90. So I'll write over here 30 plus 53 plus we say 90 degrees. Okay. I hope you got it. What I'm trying to say. Okay. Yes. Now guys, tell me how much is this? This is 50. This is 83. So this will be 173. VL of T will be, and this is I naught into XL. And I'll write sine of 100t plus 173 degrees. And what is I naught? 0.1. And what is XL? What is the value of XL? XL is 100. So this will be 100. Then we say sine of 100t plus 173 degrees. So this will be 10. And I say sine of 100t plus 173 degrees. I hope this is clear. I hope this is clear. Now tell me one thing. Tell me one thing. When it comes to VC, if this is 53, how much will be this angle? This is 37. Don't you think that VC lags VNet by 37 degrees? So I'll just write over here, VC lags VNet by 37 degrees. So when it comes to VC of T, potential difference in case of a capacitor T, so we say this is V0 potential peak voltage in capacitor. Then we say sine of 100t plus 30 degree. As of now, we are mentioning the voltage of this. Then we say minus 37 degrees. That is minus 37 degrees because it lags by 37 degrees. So this will be I0 into XC. Then I'll write sine of, this will be minus 7 degrees. Okay. And what is I0? 0.1. And what is XC? That is 500. Then I'll write sine of 100t minus 7 degrees. So this will be 50. And then I'll write sine of 100t minus 7 degrees. I hope this is crystal clear to each and every single student. Guys, please give me the signal in the chats. And if you have not liked the session yet, I would want you guys to smash the like button. Tell me, is this clear? We have this question over here on the screen. Okay. In a series LCR circuit, the voltage across the resistor inductor, the RMS voltage across the resistor inductor is 400 volt, 700 volt. So across this resistor, it is how much? 400 volt. Across inductor, it is 700 volt. Okay. If the applied voltage is this much, this is the applied voltage. We are supposed to find the peak voltage across capacitor. We are supposed to find what is the value of V0 across capacitor, peak voltage across capacitor. See. In the question, it says that VRMS, okay, in case of resistor, this battery supplies the voltage to resistance, to inductance, to capacitance. And RMS across this is how much? That is given as 400 volts. And then it says VRMS across inductor, that is given as 700. And if you clearly check, net equation is this 500. We say root 2 sine omega t. Could you please tell me what is the value of net VRMS? Guys, we can say VRMS and it is net. How to find, if this is the equation, how to find VRMS? That will be simply V0 divided by root 2. And what is peak over here? Peak in this case is we say 500 root 2 divided by root 2. This and this will cancel. So it will come out to be 500. So we say net VRMS is given as we say 500 volts. Now plot these on phasor. Plot these on phasor diagram. Okay. I would want you to plot these on phasor diagram. Now guys, listen and understand. We say voltage across resistance. Sir, we say this will be the voltage across resistance. That is VR. VR is in the forward direction. This will be the voltage across inductance. Okay, we are talking about RMS only. And this is given as 400 and this is given as 700. and net will be something like this, because net is over here, V net is over here, that we got as 500. Okay, and we know this will be VC. Guys, tell me one thing. What should be the RMS value of VC? See. Here it says 700. Here it says 400. Do you think that net of 700 and 400 is 500? No. Net of 400 and 300 is 500. If this is 300 here, this is 4, then only it will be 5. So it is only possible if the value of this is 400. If you keep this 400, this 7 minus 4 will become 3. So we say then we say this will become, it will become something like this. This will become 300. This is 400 in the forward direction. This is 300. Then only net will be how much? 500. We say it is only possible if VC is 400. So if they are saying net is 500 here, so means we can clearly say VC is 400. It is, then only we can say this is correct. So now, so here, if VC is 400, then only V net will be, then only V net will be 300, 500. So what we finally got is, we got VRMS in case of capacitor, that we got as how much? 400. If we know VRMS, how can we find peak? We know, sir, when it comes to the peak, it is simply VRMS into root 2. Because VRMS is peak by root 2. Peak will be VRMS into root 2. So that will be 400 root 2. So I can say in this question, so potential difference, peak voltage across the capacitor is 400 root 2. That's what we were supposed to calculate. Okay. Cool. Let's talk about this one first. See guys. Power in AC. When it comes to the current electricity, guys, I have told you over there, this is the resistance and this is the battery connected to the resistance. If you remember, I told you, sir, power supply by the battery was V into I. Power means how much energy is supplied by the battery every second. So V was the potential difference, I was the current. So this was the power supply by the battery. And this is in case of DC source. Okay, in case of DC source, V into I. When it comes to the power in AC circuit, if the circuit is having the alternating voltage, alternating source, how much will be the power? Shall I write V into I or something else? Guys, power means how much energy current battery is supplying. So it is voltage multiplied by current. This is the DC in case of DC source. Here I write simply in an AC circuit. When it comes to the power, we simply say it is VRMS IRMS into cos of phi. There we write V into I. Here write VRMS IRMS into cos of phi. This is how we find the power. Now let's suppose if we have in pure resistive circuit. Tell me one thing. In case of pure resistive circuit, we say voltage and current VR and I are in the same phase. So here phi is equal to 0. Okay. So between these two, what is the phase difference? 0. So I can say power in this case will be VRMS into IRMS. Okay. And cos 0 is 1. Okay. And then if we talk about in pure inductive circuit, in pure inductive circuit, we say this is the voltage, this is VL, and this is the current, and we say here phi is pi by 2. And can I say in this particular case, if I define the power, you say VRMS into IRMS into cos of pi by 2. Cos pi by 2 is cos 90, that is 0. So we say in this case, this is 0. So we say this pure inductive circuit, it's a wattless circuit. Power is 0 here. Now, if I say in case of pure capacitive circuit, in pure capacitive circuit, can I say this will be the voltage across capacitance and this will be the current, and this is basically pi by 2. Here current leads by pi by 2. And in this case also you can say power will be simply VRMS, IRMS, then cos of pi by 2, and here also power will be equal to 0. Then if you have an LCR circuit, we say in case of an LCR circuit. Guys, tell me one thing. Let's suppose if it is capacitive in nature. This is capacitive in nature. This will be capacitive in nature. So this is XC minus XL. This is R, and this in this case will be, let's suppose, Z. Okay? And this angle is, we say, sir, phi. And what is the value of Z? Under root of R square plus XC minus XL whole square. And what is the value of this tan phi? X, this by this, okay? And in this case, if somebody asks you, what is the value of cos phi? Cos is base by hypotenuse. Base is R, hypotenuse is Z. That will be R by Z. And this is also what we call power factor. Power factor. Cos phi. Now tell me, in case of an LCR circuit here means in which inductor is present, capacitor is present, resistance is present. And you are supposed to find what will be the power over here. So power will be simply, that is VRMS, it is IRMS, it is cos of phi. So you can say this power will be VRMS. What is the value of VRMS? Keep it as it is. And then we say IRMS. Okay. And then we say cos of phi. And what is the value of cos phi? And that is R by Z. This is how you find the power in case of an LCR circuit. Let's suppose you are given a question something like this. In an AC circuit, V and I are given by this one and this one. Okay. Guys, let's find VRMS first. We say VRMS in this case is, this is the peak voltage. That is peak divided by root 2. And this is the peak current over here. I is equal to I naught by root 2. Peak divided by root 2. And it is in the milliampere. So I would want you guys to multiply with 10 raised power minus 3 in order to convert into the ampere. Okay. Now, and you can clearly see it is here. It is 100 sine of 100t, 100 sine of 100t plus pi by 3. So phase difference between the two is given as pi by 3. You are supposed to find the power. Can I say here power will be simply VRMS into IRMS into cos of phi. So P is equal to, what is the value of VRMS? That is 100 divided by root 2. What is the value of IRMS? 100 divided by root 2 into 10 raised power minus 3. And then we say cos of pi by 3. Cos 60. Solve it, it will come out to be, check it, how much it will come out to be. Okay, I think it will be 2000 watts, something like that, 2500. Tell me guys, is this clear to each and every single student? Is this crystalline clear? Okay. Next. Let's take a look over here. Variation of impedance with the frequency and different circuits. Guys, see, let's suppose you have got resistance, you have got frequency. When it comes to the resistance and when it comes to the frequency, I say there is no relation between resistance and frequency, so the graph will be straight line. There is no relation between resistance and frequency. So in pure resistive circuit, okay, in case of pure resistance, graph will be the straight line, okay, no relation. But my dear friends, when it comes to the inductive reactance and frequency, guys, listen to me very carefully. We say XL is equal to omega L. Omega we can write 2 pi F into L. Now clearly you can see from here, this XL is directly proportional to frequency. So the graph will be straight line. XL is directly proportional to frequency. Now graph between XC and F. We say XC is equal to 1 upon omega C. And XC you can write over here 1 upon omega means 2 pi F into C. So you can say XC is inversely proportional to frequency. So graph will be rectangular hyperbola. Okay. Yes. Now, graph between impedance and frequency. Guys, see. If I say, when it comes to the LCR circuit, what is the value of impedance? Impedance is under root of, we say R square plus, either you say XL minus XC or XC minus XL, one and the same thing. XL minus XC whole square. Now guys, I would want you to understand one thing. Can I write it something like this? Z is equal to, we say this is R square plus, when it comes to this XL, can I write it omega into L minus? When it comes to this XC, can I write it 1 upon omega C? Yes, whole square. So now this Z will be under root of, this is R square plus, guys, omega into L. Omega we can write 2 pi F into L minus 1 upon omega C. I can write as 2 pi F into C. Okay. And it will be whole square. Now comes the question. See, what if I say, if frequency is 0, let's keep the frequency 0. Okay. We said this term will become 0. This will become 1 upon 0. This will become 1 by 0 is infinity. Now this term is infinity. So we say R square plus infinity. So this will become infinity. In that case, we say Z will be infinity. When frequency is 0, Z is infinity. Cool. Then, if frequency is infinity, if we keep frequency large, we say 2 pi into infinity becomes infinity. Minus 1 by 2 pi into infinity, this will become 0. 1 by infinity is 0. So infinity minus something will be infinity. So infinity plus R square is infinity. In this case, Z is infinity. When frequency is 0, Z is infinity. When frequency is infinity, Z is infinity. Okay. Third condition. If I say, if XL is equal to XC, by any chance if both comes out to be equal, can I say in that case, Z will be, this and this are same, so this minus this will be 0. Z in that case will be under root of R square. This and this will cancel, Z will come out to be R. These are the three conditions. Let's plot the graph. Graph between impedance and frequency in case of LCR. See, when frequency is 0 here at origin, Z is very large, infinity, so graph starts from here. Okay? And when XL is equal to XC, then impedance will be R. Impedance will be R. And then it says, when F is infinity, F means large over here, Z will be also infinity. So then graph increases something like this. So when frequency is infinity, Z is equal to infinity. When frequency is 0, Z is equal to infinity. And here, when XL is equal to XC, then Z is equal to R. And this is called the minimum value of impedance. So minimum value of impedance is at X is equal to XC. Minimum value of impedance is at X is equal to XC, my dear friends. Okay. Okay. Smash the like button, guys, if you have not liked this session yet. Okay, so this is the graph of this. Now, let's take a look at this question. In the following circuit, okay, E0 is given this, R is given this, L is given this, okay, frequency is variable. Then the current at frequency is equal to 0 and F is equal to infinity. Guys, in LCR, when frequency is 0, Z is infinity. Means impedance or resistance is very large. If resistance is very large, we say current is equal to, we say V divided by R, impedance, potential difference by resistance. Resistance means impedance. So I is inversely proportional to Z. If Z is large, current will be small. So if Z is infinity, current is 0. 1 by infinity, current will be 0. And when frequency is infinity, impedance is infinity. And current will be 1 by infinity. So current will be again 0. So when frequency is 0, current is 0. When frequency is infinity, current is 0. 0 and 0. 0 and 0. Let's talk about the resonance condition. What is a resonance condition? In an LCR, if XC is equal to XL, in an LCR circuit, if XC becomes equal to XL, then this is called resonance condition. Then this is called resonance condition. Okay. And in this case, we say impedance will be under root of, we say R square plus, we say XL minus XC whole square. Okay. When in an LCR circuit, if XL becomes equal to XC, then we say this is called the resonance condition. And here, don't you think that both are equal? So this term will be 0. So this will be under root of R square. This and this will cancel. So Z will be equal to R. This is called the minimum value of impedance. And this is This is evident from the phasor diagram also. This is R and this is XC, this is XL. If both becomes equal, then they will cancel out. So Z will be equal to R. Net resistance will be equal to the net impedance is equal to the resistance. Yes, this is called the impedance, resonance condition. Okay. And now in this particular case, we say since XL is equal to XC, can I write this as this is omega L and this is 1 upon omega C. Now take this omega over here. This will be omega square is 1 upon LC. So omega will be only 1 upon under root of LC. And then this is called resonant angular frequency. This is called the resonant angular frequency. Okay, yes. Now we say also this omega is 2 pi f. So I can say this will be equal to 1 upon under root of LC. So can I write over here this f will be 1 upon 2 pi under root of LC. Okay. So we say this is called resonant frequency. This is called the resonant angular frequency. This is called the resonant frequency. Keep both of these in your box. This and this. Okay. In an LCR, L is 800, C is 500. The resonant angular frequency will be directly you can use 1 upon under root of LC. Just put the value of L, put the value of C and you will get the answer. Now it will take us 30 minutes more and we are done with this chapter. Okay, ladies and gentlemen. Now guys, take a look over here. Radio tuning and quality factor. Let me make you understand radio tuning and quality factor. See guys, let's suppose we have a radio over here. This is a radio. Okay. So I'll make it something like this. Guys, have you ever seen a radio like this? Let me know in the chats. Have you ever seen a radio like this? So this is a radio, this is a switch. This is one more switch. This is the bigger one. Okay. Okay. And here you get bands 92.3, 93.5 FM, 93.8 FM, something like that. Okay. This is a radio. Have you ever seen? Yes. And my dear friends, we say in this radio an LCR is used. This is L, C and R. It is not visible though, but I'm showing you over here so that we can understand L, C and R. So in a radio, LCR circuit is actually used. Okay. Now guys, we say if we have to listen to a band in this radio, if we have to listen to a particular band, particular band in the radio. What we actually do, we basically scroll that jockey. Like if this is 98.5, I want to listen to 98.5. Okay, I want to listen to 98.5. So we scroll the jockey and place it at 98.5. Then we are able to listen to that. That is how we actually do. So we say, if we have to listen to a particular band in the radio, we scroll the jockey. Okay, jockey, which is present over here. We scroll the jockey. Okay, and place it on that frequency. So what are we actually doing? Then we are able to listen. I'm saying I have to listen to this band. So you scroll, you place the jockey over here. Now I can listen what is running on this band. So what we actually do in reality is, so in reality, we make the resonant frequency of LCR. By scrolling, we are making the resonant frequency of LCR equal to the frequency of that band. Resonant frequency of LCR equal to the frequency of that band. So I'm saying this frequency, I'm saying you have to listen to 98.5 FM. So the frequency of this LCR, you have to make it equal to 98.3 FM. 98.3. When you make it equal to this, then I say you would be able to listen to that band. This is actually how this radio works. Okay? Yes. Now guys, I hope you are able to understand. Simply, if you want to listen to any band, you make the frequency of LCR equal to frequency of that band. You will be able to listen to that band. Okay, cool. Now guys, one more thing. I say, plot the IRMS graph from impedance graph. Guys, we recently saw the graph of impedance. That is, this is Z versus F. That was something like this. Okay. Now, initially, Z is large, Z is infinite. Finally, Z is infinite. Here, Z is minimum. Okay. Now, if we want to make the graph of current from the same graph, guys, understand IRMS versus frequency. And this was the Z was when it was resonant frequency. At resonance, F naught, XL is equal to XC, and value of impedance came out to be the minimum. Value of impedance is minimum. Now guys, when impedance is large, don't you think that current will be less? We already discussed. Current is inversely proportional to resistance. Resistance is more, current will be less. So graph starts something like this. So when impedance is large initially, when frequency is 0, impedance is large, so current will be less. And when impedance is minimum, we say in that case at a resonant frequency, we say this current is large, peak current, I naught. And again, when Z is large, impedance is large, we say in that case, current will be less. This is the graph of current in this LCR from the impedance graph. Is this graph clear? Please tell me in the chats, guys. Please tell me in the chats. Okay. Now, guys, understand one more thing. See what I'm trying to make you understand. See, what I'm trying to say is that, if impedance is large, resistance is large, we say current is inversely proportional to impedance. If impedance is large, current will be less. So initially, we say current will be less. When impedance is minimum, current will be large. Okay, at F naught. Then again, current will decrease. Now, let's suppose I'll take two radios over here. Okay, let's take two radios. I'll say, let's take two radios. Okay, so I'll make it over here. This is the radio 1. This is the radio 2nd. These are the two radios that I'm taking over here. Okay, this is the radio 1, this is the radio A, and this is the radio B. This is radio B. Okay. Okay. And I say this is a radio 1 and this is radio 2. Okay. Now guys, I'm saying graph of current IRMS versus frequency for this radio A came out to be something like this. Graph of current between current and frequency, IRMS and frequency, it came out to be something like this. Okay. Now, what is the difference between the two graphs? Understand this very carefully. We say, sir, this is the peak current over here. Okay. And you are getting this peak current at this F naught. Even if you check this frequency, that is F1 over here, if you check this frequency, that is F2 over here, don't you think this current is almost same? So you are getting this peak current at three different frequencies. In this radio, if the graph is this, you are getting the peak current almost at three different frequencies. But when it comes to this, we say, you are getting the peak current. We say, let's suppose this is F naught, only at one frequency. And here this is F1, here this is F2, this is F1 and this is F2. So you are getting the peak current only at one frequency, that is F naught. Here you are getting peak current at three different frequencies. So from this, we say quality of this radio, I can say quality of second is greater than quality of first. What does that mean? Quality means how good the radio is. Quality factor, how good the radio is. See guys. What does it mean? Have you ever experienced this in your life? You are setting up the band in a radio. Then you are setting up the band in a radio. Once you are doing that, at the same time, my dear friends, okay? At the same time, you are able to listen to 2-3 bands. Even you get some different noise over there. You are able to, if you have to listen to 93.5 FM, okay, one band. Now, once you basically put this jockey, once you basically scroll this jockey and place it onto 93.5, you are able to listen to 3 different bands at the same frequency. And you don't get the clear voice. You don't get the clear voice over here. And you don't get the clear sound in this particular case. So we say the quality of that radio is bad. Quality factor of that radio is less. That is what happens over here. You are getting the peak current at 3 different frequencies. That's why you are able to listen to 3 different bands at one frequency. Okay, so it is a mixture of 3 different bands you are hearing. So it's not a good quality radio. But here, you are getting the peak value only at one frequency. Means once you select 93.5 FM, you will get the crystal clear voice over there and you would be able to listen to this band very properly. No noise will be there. So we say quality of this radio is better than this quality. We say in radio 1, we get to hear three bands at the same time, and we get to hear three bands at the same time. Okay, and quality of this radio is bad. And in this case, you are able to listen to only one single band at a time. Okay. Now guys, one more thing I just want to tell you over here. This is what we call this is what we call delta F, that is bandwidth. Okay, we say this delta F is what we call bandwidth. Okay, and here this is the delta F. Now if the graph is wider, we say bandwidth will be large. This has got the large bandwidth, this has got the small bandwidth. Okay, if bandwidth is large, we say quality factor is less. And always remember, when it comes to the quality factor, it is basically angular frequency divided by, we say, bandwidth. So means quality factor is inversely proportional to the bandwidth. So if bandwidth is large, you see bandwidth here is large, quality factor is less. So that's why I'm saying this is not a good quality radio. You want to listen to a particular band, you are able to hear many voices. That's why it is not a good quality radio. Quality factor of this is less than the quality factor of this. Okay. And one more thing, sir, this bandwidth delta F, this is equal to, we can say R divided by L. We can say this is equal to R divided by L. Resistance of LCR divided by inductance of LCR. And this was asked in NEET 2021, NEET 2021. This bandwidth is equal to R by L. Now tell me, can I say from here, this quality factor Q is equal to angular frequency is omega divided by bandwidth is delta F. So this will be delta F. So quality factor will be omega upon, we say R by L. L will go in the numerator. So can I write over here, this quality factor will be omega into L is simply XL and divided by, we say, sir, R. This is the formula of quality factor. Even we can say as at a resonance, we say XL is equal to XC. Can I not say this Q will come out to be XC divided by, we say, R? Okay, this is also the formula for quality factor. Even you can write it something like this. Q is equal to, what is the value of XC? 1 upon omega into C. Okay, 1 upon omega into C into R. This is also the value of quality factor. Okay. Okay. Now take this equation. Equation first. Okay, take this equation first. I'll just mention over here. We say as this quality factor is omega into L divided by R. Omega into L divided by R. SCCC. Can I say in this particular case, can I say put in this as omega is 1 upon under root of LC. So put it over here. Q will come out to be, this is L upon R under root of LC. This is instead of omega 1 by LC, 1 by root LC. Now I want you to multiply with root L and divide with root L. Guys, see. Here we say this root L and this root L. This root L and this root L. We say this root L and this root L will become L. Root L into root L will become root L whole square, so it will become L. This L will cancel with this L. So we say Q will come out to be, in the numerator it is root L, in the denominator it is root C over here. Then we say 1 by R. So Q will come out to be 1 by R under root of L by C. This is the quality factor in terms of R, L and C. This is the quality factor. Quality factor in terms of R, L and C. This is the quality factor in terms of R, L and C. This is the important equation. Okay, this is the important equation. The last topic of the today's session, next 15 minutes is going to take. This is the maximum detail in case of the quality factor. Keep that thing in your mind. Okay. Now guys, let's talk about the transformer. Let's talk about the transformer. Let's talk about the transformer. Guys, we said transformer is a device which is used to step up or step down the alternating voltage. Tell me one thing. This is your house, beautiful house, okay? And inside your house, you have television, you have refrigerator, you have washing machine, and other electrical instruments. Now guys, we say supply is coming from the outside. Don't you think that you have the transformer at your home? The supply that comes from the outside enters this transformer. Then from the transformer, you give the supply to television, you give the supply to washing machine, refrigerator. Why don't you directly connect this supply to television, refrigerator, washing machine? You say, sir, because it will burn out. If the supply from the outside comes large, then we say, if it is directly connected to this, it will burn it. It will burn the refrigerator. It will burn the television. So for that, we use transformer. If supply from the outside comes out to be large, if that is large, we say it will step down that alternating voltage. Okay, and then when it decreases that voltage, then it supplies to the television. Then it supplies to the limited amount of voltage which actually needs. Okay, same is the case over here. Then here it supplies. Now, if the supply from the outside is less, we say refrigerator will not work, this will not work. So this transformer basically steps up. It increases that voltage and supplies over here. So basically, if you have that manual transformer, what do? You say basically tick, tick, tick. You are increasing the voltage or you are decreasing the voltage. So transformer is that device which is used to step up or step down the alternating voltage, which is used to step up or step down the alternating voltage. Okay. Transformer is that device which is used to step up or step down the alternating voltage. So we say transformer is that device which is used to step up or step down the alternating voltage. Cool. Now, how does it actually work? What is the construction? So if we make a transformer over here, it has got, this is what we call the soft iron core, this. And there is a coil which is wound over here, okay? And this is what we call the primary coil. Primary coil is that coil which takes the primary current, means the supply which comes from the outside enters the primary coil. Okay, this is the input voltage, the supply which comes from the outside, from the government is sending. Okay, that is this input voltage. This is input current. This is called the primary coil. And this one over here is called the secondary coil or secondary winding. And here it gives the output current. Like I am saying, this is the transformer. Supply coming from the outside is input supply. And then it sends the supply to the television, refrigerator, that is output. Okay. And NP is the number of turns in the primary coil. NS is the number of turns in the secondary coil. Okay. Yes. Guys, tell me one thing. Let's suppose you are sending the current over here in this coil, input current. See. We say, if I primary current enters the primary coil. We know whenever the current enters the coil, magnetic field is produced in the coil. We say magnetic field is produced. We know magnetic field is produced. If IP is the primary coil enters the coil, we know due to the current, magnetic field will be produced. And magnetic field will be something like this, this. Along the axis of the coil. This is the coil along the axis of the coil. Now, due to the soft and, we say if magnetic field is produced, so flux is produced. Okay, because here magnetic field is crossing the area of coil. Whenever magnetic field lines cross the area, flux is produced. Okay. Now, guys, let's find, let the flux through one turn is phi naught. Let the flux created through one turn is phi naught. Then how much will be net flux through primary coil? Guys, if through one turn it is phi naught, what will be the net flux through all the coils over here? What will be the net flux through all the coils over here? You say, sir, number of turns in the primary coil, that is NP multiplied by phi naught. If through one turn it is phi naught, through two turns it will be 2 phi naught, through 10 turns it will be 10 phi naught, through NP it is N phi naught. NP phi naught, where NP is the number of turns in the primary coil. Now guys, tell me one thing. We use the soft iron core. Because of the soft iron core, these field lines are deviated and we say then it will enter the secondary coil. If the soft iron core was not present over here, then it will have gone something like this. Due to soft iron core, these are turned towards the right and then they enter the secondary coil. So I'll just say, due to the soft iron core, the field lines are transferred to the secondary coil. The field lines are transferred to the secondary coil. Due to the soft iron core, the field lines are transferred to the secondary coil. So flux in the secondary coil. Now guys, if I'm saying flux through one turn over here is phi naught, and that here also flux through one turn will be phi naught. Okay, here also flux through one turn will be phi naught. Now net flux through secondary coil, that will be ns into phi naught. Okay, total number of turns in the secondary coil multiplied by phi naught, and we say this is the second equation. And this one is the first equation. Now I say divide first and second. So I can say in this particular case, flux in secondary coil divided by flux in primary coil is equal to number of turns in secondary coil into phi naught divided by number of turns in the primary coil into, we say, phi naught. Phi naught will cancel. Flux in secondary will be equal to, take it over here, number of turns in secondary upon number of turns in primary into, we say, sir, flux in primary coil. Now guys, since this current is not a constant current, this is a changing current, because this is alternating current coming from the outside. Government sends the alternating current. This is a changing current. Since the current is changing, so if current changes, we say magnetic field changes. Because of the changing current, changing magnetic field is produced, so flux will change. If flux changes, we say EMF is induced. So the current is changing, so flux is changing. So EMF or potential difference is induced. Now tell me guys, how do we write the change in flux? We say, sir, due to the change in current, flux will change. So that will be change in flux d phi s by dt into is equal to number of turns in secondary upon number of turns in primary. Then we say primary flux d phi p divided by dt, or simply differentiate this equation, one and the same thing. Or if you want to understand logically, current is changing, flux is changing, so change in flux, we write this. Now what is d phi by dt? As Faraday's law says that EMF is equal to d phi. Whenever flux through the coil changes, EMF is induced. Potential difference is induced. So I can say this will be potential difference in the secondary coil is equal to, we say, NS divided by, we say, NP into potential difference in the primary coil, EMF in the primary coil. Now I can say, you can say this is V output also is equal to number of turns in secondary divided by number of turns in primary into we say, sir, V input also. We say V input also. You can directly remember this expression. You can forget all of this, but still there are questions asked on this. That's why I'm showing you. This is we have over here. So can I say, my dear friends, in this particular case, listen to me very carefully. This is the output voltage produced in the secondary coil. It is equal to number of turns in secondary coil, number of turns in primary coil, input voltage. Now, let's suppose we talk about the step-up transformer. Okay, let's talk about step-up transformer. Step up the voltage. Guys, I hope you got the feel of this. So basically, this is the output voltage produced in the secondary coil. This is the input voltage sent in the primary coil. Because of this input voltage, output voltage is produced. And what is the value of output voltage? Here. Let's do the step up voltage. What does that mean? If supply from the outside is less, you have to increase that supply. Guys, see, if I'm saying V is equal to input voltage, V input is equal to 50 volts. Okay. And Let's keep the number of turns in secondary coil as 100, number of turns in the primary coil as 50. And let's find V output. What will be the output? So guys, V output in this case will be number of turns in secondary coil 100 divided by number of turns in primary coil into V input into 50, because this is the formula, Ns by Np into Vn. So I can say in this case this and this will cancel, so V output will come out to be 100 volts. Means if you want to step up the voltage, you have to increase the number of turns in the secondary coil. You have to keep Ns greater than Np. Okay. Now, step down the voltage. Guys, we say, let's suppose input voltage is 100. Number of turns in secondary, let's keep this as 50. Number of turns in primary, let's keep this as 100. Let's talk about the output voltage. You say output voltage in this particular case will be, that is, guys, number of turns in secondary, that is 50, divided by number of turns in primary, that is 100, into input voltage is given as 100. This and this will cancel. So V output here is coming out to be 50. So if you want to decrease the input voltage, you have to decrease the number of turns in the secondary coil. So if we have to step down the alternating voltage, we must decrease the number of turns in the secondary coil. We must decrease number of turns in the secondary coil. Now guys, let's take a look over here. So if we have to step down the alternating voltage, we must decrease the number of turns in the secondary coil. So basically, in that manual transformer, while you do this, you are saying, hey, increase the voltage. So what do you actually do? You increase the number of turns in the secondary coil. So with that, voltage output increases. And if you decrease the number of turns in the secondary coil, so voltage will be decreased. Okay. One more thing we discuss over here, that is efficiency of a transformer. Efficiency of a transformer. What does efficiency of a transformer actually mean? Efficiency means this, we write it something like this, neta. So it is simply output power divided by input power. If, guys, if I say transformer is 100% efficient, means the amount of input you are giving, output will be same. There is no loss. We say it's highly efficient. So I can write over here, P output is neta P input. And if I say, if for an ideal transformer, we say value of neta is 100. Okay, 100%. So can I write over here in this particular case, we say output power will be neta is 100%. How do we write one? Like if I say 80%, 80% will be 80 by 100. 100% means 100 by 100. So that will be P in. 100 by 100 is 1. So in that case, output power will be equal to the input power. Okay. For an ideal transformer, there is no power loss. So power input will be equal to the power output. And you can write it something like this. Power output means voltage output into current output. V into I. Power is V into I. and this is voltage input multiplied by current input. This will give you the power. Next, let's talk about this question. A 220 volt input supplied to a transformer. So V input in this case is 220 volt. The output circuit draws a current of 2 ampere. Output current in this case is 2 ampere. At 440 volts, V output is 440 volts. If the efficiency of the transformer is 80%, neta is given as 80%. The current drawn by the primary windings is, primary winding means primary coil. What is the current in the primary coil? IP we are supposed to find out. Now guys, here, we say output power simply is neta into P input, because we say neta efficiency is output by input. Now what is output power? We can say, sir, this is output, V output into we say I output is equal to, this neta is given over here 80%. So that is 80 by 100. And into power input, that is V in into I in. What is output power? Output power is given as 440. What is input power? Input power. Output voltage, input voltage. Input voltage we are supposed to find out is equal to, this is 80 by 100 into input voltage is given as 220 into input current is given as, okay, this is output current. Okay. Output current is given. I out is 2 ampere. And we say I input. So we say 221s are, 222s are. Now 2 into 2 is 4. Forget about this 8. 2 into 2 is 4. 4 ones are, 4 20s are. Okay, this and this will cancel. So it will go out. 10 divided by 2 is equal to I in. I guess I input comes out to be equal to 5 ampere. Okay. I input current is coming out to be 5 ampere. Simply I'm just using over here. Let's talk about this one. The primary windings of a transformer has 500 turns, means NP is 500. Whereas its secondary winding has 5000 turns. NS is 5000. The primary current, the primary is connected to an AC of 20 volts. V input is 20 volts. The secondary will have an output of V output we are supposed to find out. So we say V output is equal to NS divided by NP into V input. So NS is 500, NS is 5000, NP is 500, input is 20. This. Okay, 5 ones are 5, 10s are. 10 into 20 is 200 volts. Let's talk about this one. The primary and secondary coils of a transformer have 50 and 1500 turns. NP is given as 50 turns. NS is given as 1500 turns. Number of turns in primary coil? 3.2. How you are getting 3.2, bro? Let me do the calculation for you once again. How are you getting 3.2? I don't understand. See, voltage output in this case is given as 440 volts. 440 volts. Output current in this case is given as 2 amperes. At 220 volt input is supplied, means input voltage is 220. Output draws a current of 2 ampere. Output current is 2 ampere. At 440 volts, output voltage is 440. If the efficiency of the transformer is 80%, the current drawn by the primary windings, primary current. So output voltage, output current is equal to 80 divided by 100 into input voltage. Input voltage is over here 220 and input current we are supposed to find out primary current. So 221s are 222s are. Okay. Now 2 into 2 is 4. Now this 4 ones are 420s are 80. Now this 0 is this 0 will cancel out. Now this is 10. 10 goes over here and here it remains 2 and this I in. 2 goes in the denominator 10 by 2 or directly over here 2 ones are 2 5s are. I input is 5 ampere. The primary and secondary coils of a transformer are 50 and 1500 turns respectively. If the magnetic flux linked with the primary coil, flux in the primary coil is phi naught plus 4t, where phi naught is in Webers and phi naught is constant. And we are supposed to find the output voltage in the secondary coil. Guys, input voltage is not given, but flux is given. Do one thing. In this case, differentiate this. We say, sir, d phi p divided by dt. If you differentiate this, you will get the voltage input or volt, because by differentiating flux, V is equal to d phi by dt, you will get input voltage. So I can say input voltage will be, differentiation of this will be 0 because this is constant, and differentiation of 4t will be 4. So V in is 4. Now find V out. V out is V in, that is 4. Number of turns in secondary, that is 1500. Number of turns in primary, that is 50. This and this will cancel. 5 ones are, 5 threes are, 5 zeros are, 4 zeros are 0, 4 tiya 12. So 120 volts. 120 volts. Next, this question. This is a very good question actually. A step-up transformer operates at 230 volt line. Okay? A step-up transformer operates at 230 volt line, supplies a load of 2 ampere. Okay? Supplies a load of 2 ampere. So means you have got a step-up transformer. It operates at 230 volt, means input voltage in this case is 230. And supplies a load of 2 ampere. Means it supplies a load of, it gives the load of 2 ampere. So output current in this case is 2 ampere. The ratio of primary to secondary windings, NP divided by NS, is given as 1 by 25. The ratio of primary to secondary windings, NP by NS, is 1 by 25. Determine the primary current. You guys are supposed to find out what is the value of IP, primary current. Guys. This is a good question actually. We say as use power output is equal to power input. Since this is an ideal we take this as ideal transformer. Most of the transformer we consider ideal. Output power is equal to input power. So we say in this case V output into I output is equal to, we say V input divided by I input. Okay, cool. Now in this particular case, can I say, sir, this V output divided by this V input will be equal to I input divided by, we say, I output. This is the equation first. Tell me one more thing. Also, we know. Guys, what do we know? As we recently studied output voltage, can I say this output voltage by input, V out divided by V in, is equal to number of turns in secondary upon number of turns in primary. V output by V input is equal to number of turns in secondary by number of turns in primary. Now come over here. Also we know V output divided by V input is equal to number of turns in secondary upon number of turns in primary. This is equation second. Now compare these two. Now from first and second. From first and second. Sure, output by input, output by input. This by this by this. So can I say input current divided by output current is equal to number of turns in secondary divided by number of turns in primary. From now onwards, you'll remember this directly also. You won't be deriving this again in the another questions. Okay? You won't be deriving this again. You won't be deriving this again. Okay? And I say over here, what is the value of input current? Input current we are supposed to calculate, I input. What is the value of output current? That is 2 is equal to, what is NS by NP? NP by NS is 1 by is to 25. NS by NP will be 25 divided by 1. Now do the cross multiply. So input current will come out to be 50 amperes. Thank you, ladies and gentlemen. We got it. We are done with this. All the concepts we have discussed. So do comment down below. Comment down below in the comment box later on how was the session and all. Okay. So take care, guys. See you guys very soon. See you guys on the Sunday. No, not Sunday. See you guys on Tuesday. Because Tuesday I'll be completing all the complete modern physics, all the 3 chapters. So we are done with this. So do let me know in the comments and hit the like button if you're not like the session yet. And do let me know later on how was the session. Each and every single thing, okay? Yo. So take care, guys. Huh? And I have completed your magnetism recording also, that I'll be posting most probably by tomorrow only. Okay. So take care, guys. Bye-bye. Bye-bye. See you guys very soon.